Howdy, howdy, everybody. Oh, I should take my daily Tylenol, which is not great, but hopefully it'll be resolved soon. Oh, it sounds like I'm in a box because my mic was over there. Okay, we're good. Hope everybody's having a good day. Let's read some questions. And remember, if we get up to 100,000 likes on TikTok, I will put down my hair. My long flowing locks. Is plank length like a resolution? No, probably not. What it might be is it might be like an operational limit. So like we might not be able to probe at smaller distances than that because to do so would create a black hole, which would mean we would be able to see smaller than that. But that doesn't mean that it's like a resolution of the universe. Another terrible Tuesday. Let's go. Bummer. Super interested in your thoughts on the OpenAI mathematics breakthroughs. I haven't looked into them. I know that there have been a lot of like counterexamples that have been found though. I appreciate the Stephen Hawking video. I'm so tired of him being slandered over a fake story. Yeah, me too. Like, I mean, you know, from the testimony of his ex-wife, like he wasn't like the nicest human being to her, especially after he became famous. And he did cheat on her, but like, he wasn't a monster, right? He wasn't like abusing children. Many worlds or many universes? Many world, like those are not mutually exclusive. What are your thoughts on the it from bit theory binary code being the code of reality? I'm not convinced. Do you think that physics explains everything in reality? If not, does agency have room in the structure of reality? I think so. I think it probably does explain. I think probably physics is probably the bottom. Where do general relativity and quantum physics disagree? Anything that's both very, very small, like the center of black hole or near the Big Bang, and also very, very heavy. What do you think about Destiny versus Professor Dave? I went on a rant about this on this past Thursday, but essentially I think that Professor Dave is probably too close to the subject to be talking about it objectively. When he's talking about you know, the atrocities happening in Palestine, like he's personally connected to it. So, and his like his typical kind of sardonic and, you know, source-based and objective self, it changes. Something about it changes. And like I get that because it's personal, but like if it's personal for you and you're a science communicator, you should perhaps not involve yourself. I mean, like you can talk about politics, like I don't care, but like I don't know, that's my view. How many farts do I need to push the Earth to the moon? That's a calculation that you can do. What's your opinion on the origin of the universe? I don't really have one. Real general relativity and quantum physics. Oh, I already answered that. If we were hypothetically traveling in a ship at the speed of light, what would you see? Well, you can't travel at the speed of light. You could travel really, really close. But you can't travel at the speed of light. But yeah, I mean, what you would see is very, very bright lights ahead of you and very, very dim lights behind you. In your opinion, what's the best Trek show? Deep Space Nine. What are your thoughts on the universes in a black hole idea? I don't think that they're quite well supported. What is velocity? Velocity is change in position over time. Many worlds with small differences or many unique universes? Many worlds is a quantum mechanics interpretation that doesn't really allow for like the fundamental laws of physics to be different. Then there's many worlds of like inflation and cosmology and string theory. And those you could have different constants, for example, perhaps even different laws of physics. You have a favorite solution to the Fermi paradox? Yeah, the universe is big. It's big. Acknowledging that it takes years of schooling to intuit, how would you explain particle wave duality in a mathematically concrete sense to the physicist? That there isn't wave-particle duality, that all of it is waves. All of these things satisfy wave equations, therefore they're waves. They just sometimes are localized and appear like particles. I recently started my journey in math and eventually physics. Would you do a video on recommended books for undergrad tier level? No, because I don't know what are the best books. I just use the textbooks that my university's offered. I have to jump down to the bottom because I'm really behind, but I'll make sure to try to answer as many questions as I can. Rematch with Cap when? I don't know if there will be one. After I saw the video of him getting like rhetoric advice mid live stream, I don't know, man. That was kind of cringe. Dark matter was invented to explain the speed of the outer speeds of the galaxy arms, true or not? Invented is a strong word. I would say that it was hypothesized, and then it turns out that it also explains a whole bunch of other phenomena. So, you know, the hypothesis was confirmed. Define Hooke's law. Hooke's law is just the statement that the force that a spring produces is proportional to the distance away from equilibrium. From his with 729 Arab Emirate dirhams, the apostles died for the belief. You think for a lie? I don't know that they did die for a belief that they could have rejected or that they had the opportunity to reject. Does Blitz allow people to come up to explain a question? In about an hour I will. Hour and a half. Coffee or tea? I drink more coffee than tea these days, but I do like both. I have a unified theory that resolves Hubble tension, dark matter, dark energy, wave collapse, etc. Can I DM me? No, you may not. Can you explain the concept of decoherence? Yeah, so essentially, decoherence is this idea that kind of resolves a lot of these issues with quantum mechanics, like these, you know, measurement problem kind of issues, observer effect kind of issues. Basically, how we get a classical world from a quantum world. The idea is something like this. Whenever a quantum system interacts, whenever a quantum system that's in superposition, for example, interacts with the outside world, with the rest of the world that is ostensibly not in superposition, it puts the outside world into superposition because of the way it, because of the, I mean, it doesn't have to, but often it will put it into superposition by the way of how it interacts. Now, what this means is that if, depending on which superposition state you're in, you will only observe one outcome for the given quantum experiment. But the point is that those two, like let's say you have an electron that's spin up in a superposition of spin up and spin down. So for like a trillionth of a trillionth of a trillionth of a second after the interaction, the universe will be in a superposition. But, and so will your experience and all of these things. But the point is that if even one particle leaks out of your environment that you can't account for, you will never be able to know, like even just a single photon, you'll be able to never be able to know that you're in a superposition because that particle will carry away the information. You have to get rid of that. That will carry away essentially the superposition information. And so once you no longer can account for that, you're just left with something called a mixed state. And a mixed state is precisely just a classical combination of states. And so you will find yourself in one of them probabilistically, depending on if you prefer the Copenhagen interpretation, or perhaps you'll find yourself in one of them in like one of the many worlds, in a many worlds interpretation, and so on. So basically the idea is that a tiny amount of information leaking out can automatically trigger the classicalization of what was a superposition. Sorry, I have to jump down to the bottom. That was a long explainer and I missed a lot. Can you explain topological quantum field theories? How does the topology involve itself in QFT? No, I can't, because that was one class that I didn't understand well. There's one class in grad school that I took. I didn't understand it nearly as well as I would have liked to. What's the math like at the doctorate level? It just depends on what you're doing, right? Why does CERN confirm the existence of angels and demons? It doesn't. Are closed time-like curves real physically or a mathematical tool? Well, it's not clear. Most physicists are going to say that they're probably not real physically. What was your thesis on? It was on conformal hypersurface geometry. So can quantum mechanics mathematically prove the existence of other dimensions? No. That's an empirical claim. Why does wind travel uphill at a rate faster than wind traveling on a flat surface? I don't know. I've never even heard that claim. Would dark matter have its own antiparticle? It could. It depends on it depends on the, you know, what kind of particle it is, right? Isn't the finite past epistemologically preferable due to Occam's razor? No. In fact, an infinite past is simpler because it requires one fewer input point, right? Are you fluent in any other language other than English? No. Can space-time exist without matter or energy? Yeah, in principle. What do you think about the super asymmetry that Dr. Cooper? They're not real people. would the leak of a particle be considered an observation by the outside environment? The point is that yes, you might be in a superposition, but the moment that essentially, unless you can keep track of literally every single quantum or every single particle that makes up the entire universe, the moment you lose some amount of information, if that piece that you lose was part of your system that wasn't superposition, the moment you lose that information, the superposition collapses. This is like mathematically provable. Respectfully, just curious why I need help with sponsorship for Archive, because most people that it's just not worth my time, and I don't sponsor people that I don't know personally. We will have no puns here, Thaddeus Stewart. What did the physicist say when he found 2 isotopes of helium? We will have no puns will be had. I'm a student and an independent researcher in physics. How would one go about it in general, trying to construct a QFT in general relativity? Go look up who did this first. Okay, well, Hawking did some. You basically look up QFT in curved spacetimes, and that's the kind of thing that you want to do. Einstein in an Einstein-Cartan-Reissner-Nordstrom system. Oh, that's probably, I wouldn't be surprised if that's been done, actually. So you could probably just do a Google search and maybe find something, and if it hasn't been done, it might be interesting. From Matt Lloyd with the £5. Hi, Dr. Blitz. Hope you're well today. Do you think we'll have a unified theory of everything in our lifetime? I hope you have a great stream. Well, I have no idea. I can't predict the future. I know I say this a lot, but asking me to predict the future about what will happen in physics in the next 5 years or in our lifetime, like, I can't know. But I do appreciate the question. I do appreciate the support. Are you a supporter of the strong theory, or do you think it's using up too much resources? I think you mean string theory, and no, I don't think it's using up too many resources. I have to jump down to the bottom again. You guys are asking a lot of good questions. Thank you, guys. If you're so smart, you can see the future. What is written on the blackboard behind you in a lot of your videos and your profile picture? It's just some scratch work from when I was a grad student. Do you know enough about math to debate this guy on TikTok that claims math and calculus are wrong? Probably, but I'm not going to, because I think he's just trolling for attention. How are you, doctor? I'm okay. Opinion on causal set theory? I'd love a YouTube short about it. Well, I will know more about it in a few weeks or a few months when I've spent more time working on it, because I'm working on a project involving it. So hopefully I'll have more to say then. Does our best model of the universe support quantum inflation theory? Does your personal opinion differ? So there are a lot of models. I'm not fully convinced that inflation is correct, but there are a lot of people who are. Can you share about your observation of the Trifid Nebula? Cool background. Yeah. I made a video about, or I didn't make a video about it. So I did a sponsored video for a telescope company about a month and a half ago or something like this. And they sent me a telescope, and they also paid me some. They sent me a telescope to make the video, and ever since then I've been basically using the telescope every night to just take cool pictures. And so the Trifid Nebula seems like it was actually the most impressive and the most successful. Basically, I set it up in the backyard. I programmed it with my phone to go take 3-minute exposures and then stack them all, and it came out really nice. Why won't you debate Elliot? Because he's a coward. He refuses to come on my show. He refuses to let me on his. Remember, if you're spamming, I will definitely not answer your question. Does the length of an astronomical unit change as the universe expands? No. So what is the case is that because the universe is expanding, the astronomical unit is slightly larger than it would have been if the universe isn't expanding, but it's not like continually expanding. It's just like stretched slightly more, and then it just hangs out at a new equilibrium distance. Can you explain why changing electric field creates magnetic field and vice versa? Nobody explains it and seems to understand it. Look, so the point is that the electric field alone is not a what's the word? It's not a coordinate invariant thing. It's not a tensor even. And if relativity is true, which it is, then it should be the case that we should be able to capture the electromagnetic field or the electric field as some part of some coordinate independent, some frame independent tensor. This is what it means for it to be an observable, right? If it's not one of those things, then it's not an observable. at least in classical physics. And so the way to do this is you shove the electric potential and the magnetic vector potential into a four vector. That is now coordinate independent, or a frame independent. It's a vector in this case. And then you can take its exterior derivative, and you get an electric field and a magnetic field exactly popping up in something called the electromagnetic tensor. And it turns out that when you do a Lorentz transformation, the electric field becomes the magnetic field, and some parts of the magnetic field become the electric field, and so on. And so this explains how an electric field that is moving from place to place, i.e. it's changing, can give rise to a magnetic field. That's roughly the idea. Yeah, don't forget to subscribe, to follow, to like, to, do all of these things if you want to support me, if you like this kind of content. All right, I have to jump down to the bottom because you guys are asking so many questions. Is time anything else? The causality and passing time? I don't know what that question means. Y'all into astrophysics, and I'm here trying to learn about arm wrestling. Sorry. Any advice for someone graduating with a physics degree who's not trying to get their PhD? Learn to code, or learn to vibe code, or something. Either learn finance, learn accounting, or learn software. What's the best textbook for learning electrodynamics? I found that it's electromagnetism in the case of the book that I'm about to mention, but Griffith's E&M book is very good. Do you use any local AI to organize your debate arguments? No, I don't. I just have a Google Doc. Have you heard of the amplitude-hedron? What do you think of space-time being an emergent property rather than fundamental? So first, yes, I have heard of it. I personally know one of the people who developed it. As far as space-time being emergent, I also think it's a very interesting idea. I'm not convinced, I'm not sold on it, but I wouldn't be surprised if it were true. How do you make sense of Wilsonian RG in curved spacetime? There is no invariant notion of short distances, so integrating out short distance modes doesn't naively seem to make sense. Yeah, this is one of the issues, right? It's not like I'm not clear about Wilsonian RG and curved spacetime either. Like this is, it makes perfectly good sense in homogeneous spacetimes, which can be curved, but in a generic spacetime, it's not so clear, right? And in fact, doing quantum field theory in a generic spacetime is generally very hard. How should a non-physicist think about emergence, and does this idea rule out the property of consciousness? You should think about emergence as just the same kind of thing. You should think of emergence as really, really complicated dynamics giving rise to seemingly new things when you zoom out. And the best example is that like the actual intramolecular or the intermolecular dynamics of like 2 H2O molecules or like 100 H2O molecules bouncing around is really, really complicated. But when you zoom out enough, you get hydrodynamics. And so like that's like a new feature that is not obvious from the reductionist view. Does Tolman entropy ruin cyclical models? No, not all of them. You didn't explain why electric fields create magnetic fields, you just explained how it is imagined to work. Okay, well, physics is not in the business of explaining why. It's in the business of explaining how. From Matt Lloyd with the £5. Thank you so much, Matt. I'm out of questions until I finish my Sean Carroll books and know a bit more, but have to have an extra $5 for support. Well, I appreciate that. Thanks, bud. It's very appreciated. Is it really worth it to learn to code with the current state of AI? Who knows, man? Are electricity and magnetism two sides of the same coin? No, but they are very closely related. Why is there more matter than antimatter? Nobody knows. This is one of the biggest open questions. If they say gravity is space being warped, why do things fall into the warping? There is nothing to pull. It's not space being warped, it's space-time. And so everything is always moving through space-time. And so if something's moving through space-time, then if that space-time is being warped, that path through space-time can be redirected so it's closer to the thing that it's falling towards. What physics results make you so confident the white holes are false? So I've read a few papers on this. Basically, there's a lot of instability stuff that happens. If white holes exist, it seems like the only way that they could exist is if they're very, very tiny and last for a very, very short amount of time. Also, there's just some problems with like, the thing about white holes is that they are, in some sense, require like some initial conditions that must have been there eternally, which that seems very problematic. like just some fixed initial condition that's just like the white hole in some sense would just be built into the universe. It wasn't something that happened. I heard electromagnetism does not work. Is this true? No, of course not. You may have heard magnetism does not work, but that's not quite true either. What is your personal opinion regarding LLMs and the claim that they will lead to some sort of AGI? Do you think more AI breakthroughs are necessary, or that scale alone is enough? I don't know. What caused expansion of spacetime? Well, currently the expansion of spacetime is being driven by something that we call dark energy, and we call it dark energy because we don't know what it is. But it's something. Something is doing it. From the gibberish name with the 729 AED, what ultimately caused the universe, or was it eternal? I don't know. It's hard to say. But if by the universe you mean the entirety of physical spacetime, if that is the entirety of physical reality, then it's probably the case that the universe is not the kind of thing that has causes. From Angry Beard with the 50 Swedish kroner, do magnetic monopoles exist, and what are they? If they do exist, we haven't found any. There's good reasons to think that they do exist, but you know, that's all fine and dandy. But if we can't find any, we can't prove it. Oops. Magnetic monopoles are basically just like singular magnetic charges. So you would think of it as like just a north pole of a magnet or just a south pole of a magnet. That would be the idea. Can you explain what is actually the spin? So spin is an intrinsic property of particles, some particles anyway, meaning just like how mass or charge are intrinsic properties of particles, mass even less so. Just like how charge is an intrinsic property of a particle, it has to do with the way that it's connected to the electromagnetic field. Spin is related to the way that the particle is sort of attached to the four-dimensional spacetime that we live in. Was there faster than light travel during inflation? And if so, how? No, there wasn't. Nothing moved faster than light relative to anything else. Well, except light, perhaps. Well, light didn't move faster than light, so. In quantum mechanics, what is a pure state? Have I ever seen one? So a pure state is just a state that can't be, that isn't okay, no. There's mixed states and pure states, and then there's entangled states. Yeah, okay. So a pure state is just it's a state that isn't mixed. What that means is that it is for example, a one particle state in some superposition of eigenstates would be a pure state. But you can take probabilistic combinations where there's like classical uncertainty, and those would become mixed states, not pure states. Now, have you ever seen them? Presumably, yeah, but that's just because the classical states that you observe are going to be pure states as well. They're just not quantum. The difference between a pure state and a mixed state is about kind of classical probability, not the quantum kind. From Angry Beard with the 20 Swedish kroners, how do you know all national currencies? I lived in Europe for a while, and I did my best when I started getting super chats to learn what the national currencies are that I didn't know. Because I don't want to, you know, A, waste time, and B, insult anybody. So space-time warping causes curvature that redefine what a straight path is, and orbits are caused because massive objects tend to go in straight lines, and curvature changes what straight means. Yes, except it's not just massive objects that go in straight lines, it's all objects. Do you think gravity and magnetism are related? No, not really. Except insofar that large magnetic fields can produce gravity because they have energy. Do you think true physical singularities are possible? No, I don't think so. Best book recommendations on gravity and GR? John Carroll's Space-Time and Geometry is very good, in my view. Oh. Do you think there's somehow a way to achieve FTL anything? The only way would be warp drives, and I suspect probably not in that case. Why do modern liberal physicists instinctively reject J.J. Thomson's plum pudding model with no real evidence? My guy, you're like 110 years out of date. Ernest Rutherford proved that the plum pudding model is false. Is Eric Weinstein's point that we're trying to quantize gravity rather than make quantum geometric a mischaracterization of what physicists are doing? No, plenty of people are trying to do both. Why is it that when two objects are moving together near c speed, their max observed speed is c? It's just because of the way velocities add. In a universe like ours, and there's some nice geometric features and nice geometric reasons as to why, but in a universe like ours, velocities don't add in the normal low speed kind of intuitive way. Do you do any philanthropy? I mean, I volunteer my time quite frequently. If you mean like donate money, I don't know if I have enough money to be doing that. Not that I'm like brokey, but I don't know if I'm at a place where I can, like, aside from, just giving money to like homeless folks on the street or whatever if they need it, but like to like set aside like significant chunks of money to donate, I don't know if I'm at that point where that's economically or financially smart. How much does prestige of the program matter versus who your advisor is? If your advisor is famous, then the prestige doesn't matter, but your advisor is more likely to be famous if your program is prestigious. From So Awesome, So Amazing with the $2 for dibs. Dibs on what? What do you think about the Bayesian fine-tuning argument? I'm not convinced by it. From William Matz with the $5. Thank you so much, William. Bartender, we don't serve FTL particles here. A tachyon walks into a bar. That's actually a good joke that I've liked for a long time, so thank you, William. Does it make sense to study physics first to work in biophysics, or is it better to take biology? It depends on what kind of biophysics you want to do, I guess. I think a lot of biophysicists actually spend a lot more time in biology than physics, so maybe do the other way, but it'll never hurt to take more physics. Other than lambda CDM, are there other cosmological models that you lean towards? Well, I kind of lean away from lambda CDM these days, but no, I don't have any one particular one that I lean towards. I just lean towards a dynamic dark energy model of some kind. Do you use local LLM for debate notes ever? No. Are all electrons exactly the same? They are, yeah. Opinion on quantum eraser experiment. It's neat. It demonstrates that, that quantum mechanics is real. What do you think about Kahn's non-commutative geometry? I'm not familiar with it. What's up in the CERN with the satanic rituals? What kind of prank was it? As far as I know, there haven't been any satanic rituals at CERN. Difference between inertial mass and gravitational mass? As far as we can tell, there isn't one. But people have been testing this rigorously for like decades, and they've never found a deviation. Could we find a naturally occurring traversable wormhole? Probably not, unless there's like some sort of exotic matter that's holding it open. Is there anything you want to say about the current state of US postdoc program? The job market is just harder than ever, that's all. Is there any evidence that both quantum mechanics and gravity are emergent from a deeper indefinitely causal framework? Maybe. Is it accurate to call a curved geodesic straight? Yeah, absolutely, especially if it's a geodesic, because then it's not even curved. How can time be defined geometrically? It's defined using the spacetime metric. So we have a spacetime metric. You have 1 minus sign and 3 plus signs. The minus sign direction is time. It's just how we define it. Is it true that there are stars older than the Big Bang? How's that even possible? No. Not true. Saw a video recently about hypothetical spherical portal physics. Never heard of it. What do you think about the book The Elegant Universe? I read it when I was a kid. It was really, really good then. I don't know how it stands up to, the test of time, if you will. But it was very good when I read it. It takes the same amount of energy to accelerate an object to 90% of c that it takes to accelerate it from 90% to 99% of c. Well, I would have to do the math, but maybe. Do you think there is an actual edge to the universe, not just the observable universe? No, I don't think so. From the gibberish name with the 729 Arab Emirate dirhams, so you don't know the cause, but no, it wasn't God. Yeah, in the same way that, like, I don't know the cause of rainbow. Well, pretend I didn't know the cause of rainbows. I could still rule out leprechauns. Can you find the surface area of a vase with topology? No, topology doesn't care about sizes and areas and volumes. From Cosmic Legions with the $5, for a particle that has mass to go light speed, it has to have infinite energy. Does it have to also have infinite mass? No. Are quarks faster than light? They are not. Is super asymmetry a real thing? Not that I've heard of. What would some applications for magnetic monopoles be? I don't know. But almost certainly, we wouldn't be able to, like, make them. Well, okay, maybe we could. Depends on how heavy they are, I guess. I don't know. That's only if they exist, though. What would classify as exotic particles? Have we ever observed exotic particles? No, these would be particles that have negative mass. No, we've never observed them. Is it possible that the universe could be infinitely old? Wouldn't that imply an infinite set of events has fully elapsed? Yeah. Yes and yes. But elapsed is kind of like inserting a particular theory of time, which is, you know, not really believed so strongly amongst cosmologists, say. Are spinors the most fundamental thing in the universe? I would say that tensors are. Spinors just being an example of a tensor, or like a generalized tensor. From the gibberish name with the 729, Arab Emirate Derms, you're 100% sure it wasn't God. How can you rule out God? I'm not 100% sure. I'm not 100% sure of a lot of things, but I can still rule things out if I'm very confident. From William with the $2, how are you today? I'm doing okay. Thank you. You only need infinite energy to accelerate to light speed, not to remain in it. Well, yeah, but this is like a non-physical thought experiment anyway. I thought magnetic monopoles happen when a super frees a permanent magnet. No. Do you think space-time is emergent? I'm on the fence about it. How come you feel that your answers are always right? Well, if I thought that they were wrong, I wouldn't say them. Photons can only travel the speed of light and effectively do not experience the passage of time or space. That's false. They don't experience anything because there's not a valid reference frame for photons. So there is no, they experience X proper time even if that X is 0. There's not a valid Lorentz transformation that gets you from any reference frame to any photon or light wave reference frame. Second, there is a sense in which you can say that photons have a past and photons can have a past, a present, and a future. At any given moment of time, you can refer to that, and in fact, you can even delineate parts of the photon's trajectory as the past, present, and future of that photon's trajectory, even from the photon's perspective, whatever that might mean. So no, I mean, it's just strictly not the case. There's something called affine time that if photons do experience, if there is a sense in which photons can experience time, they do experience non-zero affine time. This is a common misconception. Is it still true that no one really understands quantum mechanics since Richard Feynman said it? No, I don't think that's true. Do you think gravity is a fundamental force or emergent? I'm not sure either way. Thanks, Dr. Blitz. I only asked because I've heard Sean Carroll express disappointment at the postdoc program on his show Mindscape, and you saying you want to postdoc with him. Well, yeah, he hired somebody else, so I don't know why he's disappointed. He got somebody that he wanted, right? It's not like he couldn't find anybody. From the gibberish name with the 729 at Arab Emirate Durham's, what makes you so confident it isn't God? I've given this argument 100 times in my live streams. Pay attention. And from Fracast with the $2, how would an extra time dimension manifest? Like, oh, you'd be able to move through time, no problem. You'd be able to time travel. Like all causality would go out the window. It would be very, very bad if it were the case, and we would notice it immediately. From Breaking Austin with the £5. Thank you guys so much, by the way. If the atomic number equals protons with a nucleus, does that mean that the periodic table is theoretically infinite? No. So the thing is that you could try to keep adding protons, and then you would, to maybe make the periodic table infinite. But the thing is after a certain point, the protons just don't stick anymore. They don't stick in the nucleus. They just fall apart immediately, like instantaneously. And so you just can't form atoms at that point anymore. Do you think dark matter and dark energy are real, or are we missing out on some kind of mechanism? Dark energy might not be real for the reason that you just described, but I think dark matter probably is real. Could a curved spacetime have equilibrium from orbit? We can't do it on Earth. Could it have equilibrium from orbit? Yeah, sure. We have stable, like satellites are in a curved spacetime and they're orbiting the Earth. What would happen if I traveled faster than the speed of light? You can't. Does energy exist, or is it just a mathematical concept? It's a mathematical concept, right? What about the theoretical island of stability? Yeah, so that might exist at around 125-ish protons, but that doesn't mean that there is infinite stability beyond that. This would be like a small region. Kylo beat you. If by beat me you mean he got me to admit that atheism is possible, then yeah, I agree. Dark matter is the force slowing the universe's expansion. Well, it's not clear that the universe's expansion is slowing, and dark matter is not a force. From the gibberish name, what's the name of the argument so I can look into it? I don't know if these are named arguments. Just go watch the live streams. I do them once a week, and I give my reasons all the time. The live streams are on YouTube. No, Sean Carroll didn't say anything about being disappointed with a particular person, except the person that runs current administration and the policies it has enacted the past few years. Okay, yeah, that's fair. I believe that. How do you recover the Born rule, the psi-squared probabilities from within Everett, given that all outcomes actually happen? So the way that Sean Carroll and David Deutsch talk about it is they talk about self-locating uncertainty, which I think is at least plausible. Is energy a fluid substance? No. Would a 2D creature experience time in a similar way that we do? I suppose. From Gerain with the $5, could local expansion be slightly higher than average and that causes the Hubble tension? Maybe, but this is the kind of thing that's really hard to measure because things stop being local very quickly. What area of physics do you specialize in? I just finished my first year in PhD in atomic, molecular, and optical. I do mostly gravitational stuff and conformal gravity in particular. Are there any predicted elements left we can expect to find or are looking for? Yeah, they're just heavy. From Witcher, you said virtual particles can't become real, but I've heard about Hawking radiation. I've heard it explained using virtual particles near the horizon. Yeah, the virtual particle explanation is not a good one, in my view. Is slope rise over run? Some guy says it isn't. I mean, like, that's like a colloquial way of referring to it. The guy is just a troll, though. Don't worry about him. So is there a fixed amount of energy in the universe? It's not clear. The universe is finite, and there's a way to define the energy, then sure. From Breaking Awesome with the £2, can I just say thank you for sharing? Love it. Well, I appreciate that. Someone will argue if it is just a mathematical concept, how can we explain it as a mass? Mass is also a mathematical concept. Do you think singularity is matter, so something else? I don't think singularities exist. Can you explain the picture behind me? If you mean this one, oh no, you mean the diagram. It's called a Feynman diagram. In this case, it's the one loop. It's one of the one loop scattering diagrams for electron-electron scattering. Thoughts on the KG clan? It's cringe. It's like super cringe. Are my comments showing up? They are. Can the Higgs field have more connection with the working of space-time and gravity than we think? Probably not, no. Modified Newtonian dynamics might explain dark matter. It might, but it struggles with a lot of other things, so it's probably not the best theory that we have access to for this. If mass and energy are equivalent, how do we know that there is both dark matter and dark energy rather than just one? Well, matter and energy aren't equivalent. Mass and energy are. The point is that mass is the kind of energy that things have when they're at rest. And the point is that there seems to be matter, which is like a kind of stuff that seems to be hanging out around galaxies. That's different from whatever is causing the accelerated expansion of the universe. These are two separate things. And the reason we know that is because we know what matter does, and that doesn't account for the accelerated expansion of the universe, so there has to be some other thing. From Matt Lloyd with the £2, have a good rest of your day and stream, Dr. Blitz. Well, I appreciate that. I will do my best. All right, I have to scroll down to the bottom because I'm way behind, but thank you guys for being so patient. Neil Turok says dark matter might be right-handed neutrino and the smallest neutrino is massless. Any thoughts? Could be. This is the thing that people are looking into. How is an infinite pass simpler than a finite one? An infinite pass has one fewer number involved in it. How do you think I can get a degree in physics even though I'm not that great in math? I mean, in principle, it's possible. It'll just be harder. How can we just use warp drive? How can we use warp drive while the theory of relativity from Einstein says we can't go light speed? So a warp drive, Einstein's theory says you can't go light speed relative to something that's right next to you. But a warp drive, if you're in a warp drive, you're distorting space such that things right next to you are moving with you. And things outside of the distortion of space are too far away, so you can move faster than light compared to them, because there's not really a good way to compare them anyway. He's ignoring me. I'm not ignoring you. He's not reading TikTok questions. I am reading TikTok questions. I got him. If the Earth is round, why is my desk flat? True. How did the Big Bang happen? I don't know. If you could bring Newton and Einstein to our time, who do you think would be able to contribute more? Einstein, just because he has less catch up to do. Do you think the universe could be a fractal? I don't even, no, I'll just say no. Do you buy string theory or you're not convinced? I'm not convinced, but that's just because, like, you know, at the end of the day, I try to be rational about this, and physics is an empirical science, and string theory doesn't have any empirical support. How is it going to university as a physics major, and how hard is it to get in? It just depends on the school. It really depends on the school. There's no one right answer to that. Oh, how does the Higgs particle have a false resting energy state? Well, so classically it doesn't, but quantum corrections can change the potential for the Higgs field, and it can. It's not proven, but it can produce a you know, it can change the sign, for example, of higher order terms that would make it so that there's a negative, so the potential descends down to negative infinity, or perhaps descends down to a lower minimum at some larger field value, for example. Why does fabric of space just feel like another phrase for the ether? Well, maybe because it's an analogy. I mean, like, we use the phrase space-time, or the word space-time instead, and that's not really an analogy for ether. It's not really similar to ether at all. Does antimatter imply anti-elements? Yep. Yes, it does. In fact, we've made anti-hydrogen, and I think we've made anti-helium as well. In your baby quantum gravity model, you focus on quantum fluctuations of curvature. Do you think the more natural starting point for a theory of quantum gravity is curvature or the metric? Hard to say. It might even be the connection, and so it's neither curvature nor the metric, because that's kind of the natural starting place for quantizing electromagnetic fields, and people try to do this. This is how you get loop quantum gravity, if I remember correctly, but why are the developed galaxies present already some 100 million years after the Big Bang? Because they developed faster than we thought they did. Why only 3 quarks? Isn't it a sign for design? Well, there's 6 quarks, right? There's 6. Up, down, strange charm, top, bottom. There's 3 families of quarks. How long before starting your PhD did you know that you wanted to do research? Oh, like 14 years beforehand. Why do the stars we see at the horizon not go over our heads when we fly towards them? Well, it depends on where you are, but like if you're at the equator, depending on which direction you're flying in, they will. Speaking of dark energy, what did you think about timescape cosmology? Also, do you think the universe is deterministic fundamentally and quantum probabilities rise because of unknown variables? Okay, so regarding timescape, I haven't looked at the original paper. I know that it's sort of fringe, but it's not nonsense. But I haven't looked at the original paper, so I don't have a concrete... or did I? If I did, it was a long time ago. I don't have a concrete opinion on it at the moment. Do I think the universe is deterministic, fundamentally deterministic? I don't think that there are unknown variables that are giving rise to the appearance of quantum probabilities. No. Thoughts on backwards time travel? Impossible unless there are closed time-like curves, and those seem impossible too. Is it stupid to think that we don't have a quantum gravity model yet because gravity is such a weak force and it's difficult to measure its effects on a small scale? Yeah, that is actually one of the reasons. You know, this is one of those cases where we don't have access to empirical data to rely on to help build models, so we kind of have to go in the opposite direction. Whereas historically, we had access to empirical stuff, and then we developed models to explain that stuff. Is it possible to become a rocket scientist from KSP? Yes. Have you seen Michio Kaku's 3-part documentary on time? I haven't, no. Do you think space-time is fundamental or emergent? I'm agnostic on the issue. From Ripperfish with the $5, is it possible to compress photons indefinitely in a box with perfect mirrors? Also, can photons also produce a gravitational field if there were many? Yes, but eventually you'd get a black hole. And yes, there's something called the Kugel Blitz, which You can't actually get a black hole plausibly, like actually in our universe, but theoretically you could, with enough photons all shooting into one area, you can create a black hole with just photons, yeah. Someone asked, can you become a physicist when you're bad at mathematics? Quantanaut, don't hate me. You can become an experimentalist. That's not even that true. You have to have good mathematical intuition to be a physicist, because that's how we do physics. It's in the language of mathematics. From Cosmic Wide Web with the $2, how do we infer higher dimensions from our third dimension? Well, unless you have, I assume you're not talking about time, because time is pretty easy to figure out. I assume you're talking about the curled up spatial dimensions that you get in string theory, and those are inferred from the mathematics. It's not like some empirical facts that we know is true. Those are inferred from the mathematics. If string theory is correct, then it has to have certain properties, and one of those properties is only consistent when you're in a certain number of dimensions, which is bigger than 4. The feud restarts, indeed it does. What are some interesting new things the physics community is exploring that's cool to read about? Go to phys.org, there's always cool stuff there. If you could change one thing in physics, what would you change? Something like antimatter moves up in gravity? That would be neat if antimatter moved up in gravity. That'd be pretty cool. Would you recommend that a physics student get a master's or go straight from a BA to a PhD? Most of the time, if you're going for a PhD, there's no point in getting a master's in the first place. You believe moon landing? Yeah, obviously. Dumb question, but do you think AGI is replacing theoretical physics or thinkers in the near future? I don't know. Maybe. You know anything about super asymmetry? Yeah, it's from a TV show. It's fiction. What's the difference in engineering physics and the physics physicists do? I don't know. I don't really know what engineering physicists do. What would happen if you put your hand in a particle accelerator? Well, you'd have a really, really narrow beam of vaporized flesh or, you know, destroyed tissue, but not much else besides that. I mean, a guy accidentally got shot in the head by a particle accelerator because he was looking down the bore when it accidentally turned on. And he's still alive, and this happened in like the 70s or the 80s. What lies beyond the edge of the universe, another universe? It's not clear that the universe has an edge. How do you assign an energy cost to accelerating the expansion of the universe? Well, look, so you can track out the expansion rate of the universe, and then there's a formula that relates things like, it's called the Freeman equations. There's a formula that relates the expansion rate to the stuff that's in the universe, the matter, the energy, etc. And so once you know the expansion rate, you can just plug in all the stuff that we do know, dark matter, regular matter, dust, neutrinos, light, all these things, plug in all that stuff, and then you'll see that there's some stuff left over, and that stuff is your dark energy. What would happen if you put your... Oh, I already answered that. Is string theory closer to becoming closer to empirical investigation, or will it remain entirely theoretical? As far as I know, we are not any closer to a solar system-sized particle collider. But people are trying to figure out ways that we might be able to test some predictions of string theory or some like some slight modifications of the standard model that come from string theory. People are looking into that. It's just hard. What do you think about ADS-CFT? It's a brilliant idea. How does one survive the heat in Arizona? You go inside. What even is our understanding for why there are families of particles instead of just the base set? What is the explanation for thinking there are only what we've observed so far? Well, look, we just don't know. There are some things called there's something called the Kodai formula? The Kodai formula. The Kodai formula seems to indicate that there should be 3 because these say the quarks have a really, really nice formula that relates their masses, and so if there were more than 3, then it wouldn't have a nice formula, but it's not clear why that's the case. Like why they should satisfy this formula. How do you feel about Desi's challenges to Lambda CDM? I like them. I think that they're interesting and worth investigating further. So nobody understand how the electromagnetic field create each other in this planet? You too? No, I told you how. I didn't tell you why. Who do you think is more knowledgeable out of you, Ian, and Justin? We're each more knowledgeable about things in different topics. Honestly, I suspect I'm probably the least knowledgeable because my knowledge is very, very narrow. Ian knows a lot about philosophy, and also a pretty good amount about the Bible and physics as well, but he gets things wrong sometimes. And then Justin is like an encyclopedia for like ancient history and biblical texts. So what would happen to us in a vacuum decay? It depends on what we vacuum decayed to, but it would probably not be good. Isn't the cosmic microwave band the edge of the universe? No, it's the edge of the observable universe, or it's quite close to the edge of the observable universe anyway. If I look at a star through a telescope, am I looking at a slightly earlier version than the naked eye? No. You're actually looking at a slightly later version because the light has to pass through the optics of the telescope, which light travels more slowly through. God, my nose is so itchy. When that guy kept asking on Unapologetic if you were a naturalist or physicist or such, I appreciate you making it clear that there's no real border. Yeah, that's the rough issue, right? Can you explain entropy and gravity, because the two together don't make sense to me? Yeah, so, I mean, they're not necessarily intrinsically linked. Gravity is the curvature of spacetime, at least that's what our best model says. Entropy is in some sense a measure of disorder. So it's something like the, how many different ways a system could be arranged without disturbing the macroscopic properties of the system. These don't have to be related, but what is the case is that gravity makes the standard definition of entropy a little bit more confused. How do we even know the percentage of different masses like dark matter, dark energy, regular matter? Because we can count up how much regular matter there is. That's pretty easy. You basically just go look at the dust. You look at the stars, you count, make some pretty basic approximations. We can figure out how much dark matter there is by looking at, there's kind of two ways. One, we can just kind of look at how fast things orbit, and that tells us how much mass there is in local systems, but more specifically, dark energy and dark matter behave differently. So we can figure out how much regular kind of like matter there is, like matter that's like made of stuff, just using the expansion rate of the universe. Expansion rate of the universe is controlled by how much regular matter there is, or how much matter there is, so dark matter and regular matter, how much dark energy there is, how much relativistic matter there is, like photons and neutrinos. And so you can kind of figure out what those three numbers are just from the expansion rate of the universe over time. And so once we know how much regular matter there is, we can use the fact that we can figure out how much total matter there is by subtracting off the regular matter from that, and you're left with the dark matter. The energy that you're left over with after subtracting off the light and the neutrinos gets you the dark energy. What do you think is the most promising project for dark energy research? I don't know. I think that we're completely in the dark on this one, no pun intended. Would a telescope that leverages the sun's gravitational lensing be the best thing we could do for cosmology since JWST? Maybe not cosmology, but it would be a very, very good thing to do. Let's see, I have a PhD in physics. I do. Quantum entanglement is faster than the speed of light. Is the future of space travel? No, quantum entanglement is not a thing traveling. If there's only one particle in existence, could it be said that space exists without time? It depends on how you understand space-time. Because you can have gravitational waves, for example, without any particles at all, and then there has to be space-time. Will we ever observe the edge of the universe? It's not clear that there is an edge of the universe. You shoot a laser out the back of a lightspeed spacecraft, what happens to the laser? Well, spacecraft can't go light speed, they can only go very close. And it'll just travel at light speed from everybody's perspective, the laser will. If I'm moving fast, how do I know it's moving relative to what and who experiences time dilation? From your perspective, your clock always ticks at the same rate, if you're moving at a constant rate, as long as you're not accelerating. And so everybody else's clocks will appear to move more slowly, assuming that you're not in a curved spacetime, of course. Do you think you can follow physics more intuitively than applied math? Because that is the case for me. Sometimes. If it's well written, yeah. Thoughts on Professor Dave? He's a great science communicator. Does a very, very good job generally. Would it take more energy to go forward in time or more energy to go back in time? It doesn't take any energy to go forward in time. You're just doing it now. But going forward in time just means that you exist on a time like on a future directed time like geodesic. But that everything is doing that. Except photons or light waves don't travel in time like geodesics. They travel in null geodesics, but that's neither here nor there. Is spin a geometric topological phenomenon? It's geometric. You could say it's topological in some sense. Like it has to do with the double cover of certain groups and so on. Why did the universe start in a low entropy state? It's not clear it did start, but if it did start, then it probably wasn't a low entropy state. That is a good question. Why? Is there a good explanation? What do you think is the current best shot at nuclear fusion? I don't know. Shouldn't James Webb be able to see if there was life on other planets in the past? Not necessarily. We can hardly see the planets at all. What percent did you get on your test to be a physicist? There's no test to be a physicist. Do you think mathematicians can sometimes enjoy math a little too much, if you know what I mean? No. Oh yeah, so I should mention, because I keep forgetting to mention this, and so it keeps getting left out. There's a rather convenient way to support me, which I very much appreciate. It's like $5 a month, so like think of Patreon, but you can do it on TikTok, you can do it on Twitch, you can do it on YouTube, or you can go to Patreon. It's like $5 a month, and it really helps give me some peace of mind, because then I'm not relying on, if I have to cancel a live stream that day, it means I'm less reliant on the donations of a given day. It fluctuates less, which gives me more peace of mind. So if you want to support me and you have the spare cash, you can do so, and you get some nice perks. You get access to my debate notes, which are updated on the regular with new arguments and new articles and things like this. You also get some, there's like a private Discord chat channel that you have access to in the Discord server. You also get access to some emojis depending on which platform you decide to get a membership on. So consider doing it. You don't have to, but be a nice thing. From the gibberish name with the 729 AED, Arab Emirate dirhams, Noah's flood could have happened, but local? No, I don't think so. Otherwise, the Egyptians would have known about it. And they didn't. Can you explain the Paul exclusion principle for a semi-scientific layman? The Paul exclusion principle is just this idea that certain kinds of particles can't occupy the same state. Put another, a little bit more specifically, their states have to be kind of antisymmetric if you swap two of the particles out. So imagine that you had a formula that describes the state of a particle. If you have particle 1, particle 2, if you have a formula that involves state of particle 1, state of particle 2, state of particle 1, state of particle 2, state of particle 1, state of particle 2, anytime you swap them, you need to get a minus sign on your overall formula. And so in particular, if you swap them, if they're in the same state, then if you swap them, you get the same thing back, but because it has to have a minus sign, the only thing that's minus itself is 0. So you just they can't be in the same state because the 0 state is a non-state. How have you been enjoying this AZ weather? I hate it. What do physicists do in general? Like, is it more research-based or experimentally based? So experimental research is research. Theoretical research is also research. It just depends on what kind of physicist you are, right? What is the current promising theory to combine quantum physics and gravity? I don't know if there is one promising theory, although string theorists will say string theory and loop quantum gravity people will say loop quantum gravity and so on. Could you talk at all about the big bounce? No, it doesn't make it true, but it seems intuitive. Yeah, so depending on the way the universe behaves in the early universe, when the universe was small, if there's other additional features that we're not familiar with, like if gravity only allows a certain maximum density to be obtained, then you would get a bounce. If the universe ever recollapsed, instead of just collapsing to a singularity, it would bounce off of like this maximum density state, then it would re-expand again. And this could happen for a myriad of different reasons. But in order for this to happen, you also need recollapse. So there's a few things that have to go right in order for a bounce to happen. Could you explain how they got the value of the gravitational constant? So, yeah, essentially, you take two masses, you put them as fixed distance apart, and you measure the strength of the force between them. This is roughly what Cavendish did in the 1700s, the late 1700s. He had a very precise instrument. He used very, very heavy things and brought them very, very close, and they measured the gravitational force between them. That's how you can compute the gravitational constant. Where did you go undergrad, master's, and PhD? That's on my website, but I went to UC Davis for my master's and PhD, and I went to Arizona State for my undergrad. I know his volume needs to be up a hair. Really? I'm like almost blowing out my mic. What's the most complicated integrand you've come across that needed an obscure source to solve? There's a paper I wrote a few years ago, like 2 years ago, involving some quantum geometry, like quantum gravity stuff. And the integrals are really, really tough. And so I had to pull out Abramovitz and Stigan, which is a classic book where you have to, that has a whole bunch of known integrals. Hey, not cool. I'm pretty sure you haven't read every comment. You're right. I haven't read every comment. I'm so sorry. I miss some sometimes because I can't. Will we ever develop localized small wormholes for trash disposal? I don't think so. Are you smarter than Angels of Light? I think like most middle schoolers are smarter than Angels of Light. Do black holes really break down information? The idea is probably not. At least that's what most physicists think. I think I'm in line with that. God, my nose is so itchy. What's the best theory of ball lightning? I made a video on that. If I remember correctly, the idea is that the lightning, for some reason, lightning evaporates or vaporizes some silica in the ground, and then it floats up, and it's really, really hot, so it glows for a few seconds. What good reasons are there for believing in magnetic monopoles? If magnetic monopoles exist, then we can explain why charge comes in tiny packets and like a small quantized packets. If they don't exist, we don't really know why there's not why there aren't things with ever smaller charges. Why like the smallest charge is a third of an electron's charge. From the gibberish name with 729 Arabemra dirhams, why did you leave Judaism, if you don't mind me asking? Well, you don't really leave Judaism. Well, okay, I guess if you treat Judaism as a religion, you can leave it, but like, you know, I'm still Jewish, I just don't believe it, but that doesn't make me less Jewish, if that helps. From Burrs Eat Thee with the $5, what structures do you think will be most likely revealed by the CNB? Oh, that's a really good question, and I don't know. I mean, maybe if we can ever get high enough resolution like we have for the CMB, maybe we would hope to see things like gravitational wave backgrounds. That would be really cool. From DeForce with the $5 Australian, I heard the study done out of Korea about the decreasing rate of expansion had a response paper criticizing the idea. What's the current standing? The current standing is that there's tension. I think that the Korean team is probably not in the majority, just because, you know, the people that are responding to them are very famous and very highly regarded and very highly reputable. But I think it's contentious, and I don't think it's settled. To you, what's the most interesting engineering discipline? I don't find them very interesting really at all. Sorry. What branch of physics would you recommend new master's PhD students go into? Condensed matter is always the right answer because it's the one that has the most job opportunities. Do black holes work better than... Can you explain cosmic time? Yeah, cosmic time is just the clock that we use that is kind of synchronous with the universe. And what that means is that our universe is expanding isotropically. But specifically, that means that like if you're going too fast in one direction, it will look like the universe is expanding faster in that direction than in the other direction. So there is some speed that you can move relative to the cosmic microwave background radiation, where it will look like the universe is expanding at the same speed in all directions. And so when we say that when we talk about cosmic time, we're talking about what that person, from that observer's perspective, what their clock says. From Burrs Eat Thee with the $5, would those gravitational wave structures help resolve some arguments around brain bulk, or am I misunderstanding things? Well, maybe they would, but more specifically, they would help us understand what actually was going on at the Big Bang a lot more easily. Like whether there was stuff before the Big Bang, what models, like, so gravitational wave backgrounds are the kinds of things that different models of the early universe, like different models for the Big Bang, different models for like inflation and things like this, they make different predictions about the gravitational wave backgrounds. And so it'll help us distinguish between which models are more correct than others, more likely to be correct. Can you make a video on how the power grid works? That seems like more of an engineering question. Can energy be harvested from the universe's expansion or contraction? Probably not. Yeah, I suspect not. I'd have to think about it a little bit more. I've been a fan for a long time, and I'm starting a PhD in astro. Recommendations? If you're starting your PhD, you already know what you're doing. Just talk with your advisor frequently. Become friendly with them. Whoever your advisor ends up being, if you haven't already picked one out, you're going to be spending a lot of time with them, so make sure that it's not miserable. Because like I love my advisor. I mean, he's still alive. He's a great guy. I love hanging out with him. He's very funny. We get along very well. So it made my PhD experience fun, right? Like I wasn't dreading having meetings with this person twice a week. And so, you know, the biggest source, I don't know if this is the biggest source of burnout, but one of the biggest sources of burnout, or why people end up leaving PhDs, is because they can't stand their advisor, for example. Is there any point in learning theoretical physics, since AI will probably solve it all in a few years? Look, if AI solves theoretical physics in a few years, then we're gonna have bigger problems. Morphine and other meds makes your nose itchy. No, this happens sometimes, but I take the same meds every morning. Entropy is always increasing. Does it reset after a hypothetical big crunch after expansion? Maybe. Is this stream mostly on TikTok or some other platform? Well, it's on TikTok, it's on YouTube, it's on Twitch, it's on another YouTube channel. There's no such thing as Physicist. Sure there are. What do you think Albert Einstein was? Why did you not choose to become a mathematician? The secret is I kind of did. Is it confirmed to be the case that the universe is geometrically flat? It's not confirmed, but that's the evidence is consistent with it. Which leading theory of evolution do you believe in the most? Of evolution? Whichever one the evolutionary biologists say. Do you think the inflaton field exists? I'm a little bit skeptical of it, but I wouldn't be surprised if it did. Why can radio waves and microwaves pass through walls but light can't? It just has to do with the amount of energy that can be absorbed by the material in question, and it has to, or like the kinds of energy that can be absorbed by the material in question. It has to do with the wavelengths. So generally, things that are smaller than the wavelength of light are transparent to the thing. Atoms are, and so, you know, at least, okay, that's not always true. But if there's like a large gap, then you will often get transparency. The other thing is just that in order for light to be absorbed, for it to not be opaque, you need one of two things. You either need that the individual atoms in question can absorb the light, which happens for some UV light and some visible light, or you need that the crystal lattice in question can absorb the light. The crystal lattice, or whatever the structure is. But in the case of radio waves and microwaves, unless they're just conductors, of course, that's just not the case. The crystal lattice can't absorb that energy. It's not allowed by the arrangement of matter. From Burrs Eat Thee with the $5, for a particular line of questioning, I'm asking higher dimensional symmetries, neutrino background, initial conditions. What are some reading recos? Oh. Reading recommendations on like brain bulk stuff. I'm not a string theorist, so brain bulk stuff is like that's not me. And everything that I learned about neutrino backgrounds came from the papers. There's a paper by, was it by Wilczek? There's a paper by somebody who first proposed the cosmic neutrino background, and then I read a few papers about, you know, like developments to try to detect it. I was speculating about the gravitational wave stuff, though. I just assumed that we probably would see the gravitational waves more easily because they're earlier. Yeah, I don't have any specific like textbooks that I recommend, or like pedagogical introductions or something. Sorry. That's what Google's for. Please explain about the Big Bang Theory. Also, do you believe in a creator such as God? I don't believe in a creator. The Big Bang is just this idea that the universe was very, very small about 13.8 billion years ago, and it's expanded ever since. From PhD Tony, always good to see you. Do you think we need to reassess our education science communication strategies to more effectively combat distortions, misinterpretations propagated across social media? Yeah, I think so. Although I think that regulation could also help. I don't know how you would regulate it in the US, but I'm at my wit's end. Why is the upper atmosphere so cold if it's closer to the sun and hot air rises? Hot air rises because it also expands and cools. But the reason why the ground is warm is because it's the ground that's absorbing most of the light. Air is basically see-through, right? So it's not going to absorb most of the light. The ground absorbs most of the light. And then because it's hot, it gets the air near it warm. From Burziti with the $2. Thank you nonetheless, huge fan of what you do. Well, I appreciate that. God, I'm sorry. I need to just rub my nose vociferously with a tissue or something. So strange. How would you interpret many worlds if CTCs were real? It wouldn't really change anything. In 3 minutes, by the way, we're going to be changing over to the subscribers only mode, where anybody can come in and ask questions over voice, but the only people who can send messages are people who are part of the $5 a month membership things. And the reason we do this is because then those people have their questions guaranteed to be answered. Hey, are you ready to waste your 32 years so your ego satisfy? I don't know what that question means. Do you think electromagnetic repulsion truly prevents a touch? No, I made a video about this. If touch has any meaning, then no, of course it doesn't. If physics mathematician wouldn't work out, what would your plan B be? I don't know. Geology? PhD Tony, of course I know who you are. I've seen so many debates of yours. Especially with flat earthers, which I find entirely enjoyable. You know so much about geophysics that they just can't even handle it. It's lovely. Moon landing is fake because flag waved. I thought there was no wind on the moon. Yeah, the flag waved because people were jiggling it around. From Angry Beard with the 20 Swedish kroners. Hydrate? Oh, good reminder. Thank you. It's very appreciated. Also, we have some cash apps that I missed. Again, from Grimlock from an hour ago for have you sufficiently hydrated this stream? I haven't. Thank you again. And then from Rob with the $5. Do you think Trump is doing the best he can? No. Well, maybe. Maybe he is. Maybe his best is really bad. And then we have a $6.66 Venmo from Casey. Rhetoric advice for your next debate. More your mom jokes. Okay, I'll keep that in mind. Much appreciated. What are the common misconceptions that people believe in physics? Oh. That the Big Bang was the start of the universe, that's something agreed upon, that quantum mechanics is magic, basically. Those are the two big ones. Will warp drive be possible ever? I suspect not. Oh, the double slit, that's also a good one, yeah. Why can light escape from the sun, but not black holes, which have less mass? Well, black holes have more mass than the sun. But the point is that it's not just about the mass, it's also about how far away you are from the mass, and for a black hole, you can get much closer to where the mass is. Could the LHC actually create a black hole? No, it doesn't have enough energy. From Cosmic Wide Web with the $2, could different quark combos create matter in an alternate universe? I guess. In fact, we can create matter in we can create matter with different quark combinations now. Anyway, I'm going to swap over to the Everybody on YouTube, you guys can just stick around. Nothing will change except like the live's not going to cut out. But on TikTok, I am going to end the live and restart it in just a moment. So if you want to come back and ask questions, and especially if you want to join the live stream and ask questions in person, now is going to be the time to do it, but you will have to come back to the live stream after it ends on TikTok. You can also join via Discord, which is going to become available in just a moment to ask questions if you don't have TikTok. Currently, we have no way for people to join besides Discord and besides TikTok. So I'm going to end the TikTok live and we'll be right back. And we're back. Bake. We're bake. All right, cool. So this means I will be taking guests for what it's worth. What will happen to the plates if all icebergs melt? Will they raise or will the plates sink? I guess the oceanic plates could sink a little bit. The continental plates could rise a little bit. Did you manage to set up your Venmo yet? Yeah, the Venmo exists. I just don't have the account published anywhere, which I should do, but I haven't done it yet. Why is my phone being so slow? Yeah, let me pull up the Venmo. I think it's just $ Blitz PhD. Yeah, it's just, or it's at Blitz PhD rather. How can time be explained geometrically, or is that possible? Yeah, we explain time. I mean, we describe. It depends on what you mean by explain. We explain time geometrically in a very similar way that we explain space geometrically, namely as a part of the space-time that makes up our universe. Now, whether you like that or not is a different question. Whether you think that that's a satisfactory explanation for what time is just a part of space-time, that's, again, a different question. But this is a geometric description. My nose is so itchy. It doesn't happen often. In fact, I don't know when the last time it happened. Goober Dude, welcome to level 1. Thank you for becoming a member on YouTube, Goober Dudes. Appreciate you. I guess time can't really be explained apart from space since they make up one entity. Well, they can kind of be like broken down. It can be like decomposed into time and space, but yeah, they're not like, time is not like a thing that's separate from space, if that makes sense. God, it's actually really bad. Okay, I need to take care of this actually. I'm not even stressed. I know it's super red. I don't know why. I don't know why it's so red. It's just so itchy. Don't worry, I sent a text message, it's fine. Spray hydrocortisone up your nose, it helps and hurts. I think I'm not gonna do that actually. But that's neither here nor there. Well, look, if you guys want to join and ask questions, now's your opportunity. You can join on TikTok, you can join on Discord. We do have a guest on TikTok, so let's bring him up. Mikhail, how's it going?
Blitz.
Your mic is very quiet, by the way.
I'm sorry, let me move my fan out of the way. Can you hear me better?
Yeah, I think so.
Oh, okay.
What questions you got for me?
Hi, so I was recently, you might recognize my voice earlier, I was the person who denoted as Jarman, if you remember.
Nope.
Okay, so I read your paper on potential chiral structures, which was pretty interesting. I just wanted to ask, so was the point you were making basically that it would be incredibly difficult for you to like essentially morph a potential structure into a special one?
Yeah. I mean, the point is that they're generally not super compatible.
Because you said, I remember the paper specifically said that the geometry of space.
Oh yeah, yeah, I remember who you are. Yeah, I don't think we spoke, but you definitely messaged me, right?
What do you mean?
Wait a minute, are you Narman?
No.
Okay, then that's a different person.
Remember, we spoke before about theories of time and like.
Okay.
I believe it was also the way to define a physical law. But I was gonna say, you were saying something about the geometry of space specifically forbidding you from doing it most of the time. So can I ask, what are the special edge cases that could actually be possible?
I mean, it's laid out in the paper. I'd have to go look at the paper and remind myself again, but there's some conditions on the curvature, and there's some conditions on something called a homothety, the existence of a homothety, which is going to be very, very non-generic. So, you know,
Okay.
But yeah, I mean, the results. I mean, we're fixing it. Like the paper had some mistakes in it, so we're fixing up some mistakes. But the main ideas are basically correct.
Oh, the main ideas in surrounding like Riemannian geometry and like spatial Christoffel symbols.
Well, yeah, I mean, it's not really Riemannian geometry. It's kind of like Carolean geometry. But yeah, it's yeah. The theorems are almost correct. There's a few exceptions that we missed that we have to lay out. But aside from that, but yeah, these are not talking about like actual like spacetimes, right?
Oh no, I think you guys were talking about just potential spacetimes, like potential.
No, not even not spacetimes. They're called potential Carroll structures. These are three-dimensional degenerate spaces. They're not spacetimes.
Wait, what's a degenerate space? Like it
has a metric. It has a metric. It has a direction that you can travel in that costs you no time and no space.
Oh, okay, that makes sense. So it's kind of like a reduction in terms of like a spatial.
So these are models for black hole horizons.
Black hole horizons? I thought they were just general spaces.
No, I mean, well, okay. I mean, they can exist kind of more generally, but like these are models for black hole horizons.
Okay, this makes perfect sense. So it was basically like, because I was a bit confused on like for example like what are the special edge cases where I tried to look. I couldn't. I tried. Maybe I missed it in the paper, but I tried to like find where the special edge cases that these wouldn't actually be the same thing. Where no, I mean special edge cases where like potential structures could actually manage to be morphed into special ones.
That should be in the last section, in section 5. That's where I go over that.
I'll read up after. So now I wanna. So there was a slicing condition you also mentioned something about curve V or the. I don't know what that symbol is. It looks like a curvy V. Where you just like when you mean curvy in integral, do you mean like you can slice it into like flat layers, like horizontal layers?
Well, they don't have to be flat, but yes, that is what integrable means. That it can be sliced up.
Could you repeat that again?
Yeah. It doesn't have to be flat, but it does mean that you can slice it up.
Cutting out. Hold on. Sorry, could you repeat that again? Sorry, my mic cut out.
No.
You don't want. I'm sorry. What?
So when it's integrable, what it means is that you can slice up the universe, or slice up the space anyway. That's what it means.
Yeah. So what would be the difference between that and just slicing it into layers? Do you mean like?
That's the same thing.
Oh, but you said no, so I thought I was wrong.
No, I said no. They're not necessarily flat.
Oh, they're not necessarily. Sorry, I didn't quite hear that. Okay, and yeah, because I didn't. You didn't quite expand on like what it meant for the slicing. You didn't quite expand on the slicing condition, so I was like a bit confused. Like,
it's in the literature. I provided the references there.
Oh, I didn't read the references. I'm sorry. And then
yeah, this is a thing that Ashtekar talked about in the 80s, and it's pretty standard now. So I didn't really wasn't really necessary to prove that such things exist in the scenarios that we need them because it's known.
Okay. And wanted to ask one question about the Big Bang and the essentially the state of the universe before. So when someone asked you to define it, you said that the Big Bang was essentially just the expansion of the universe from like a very from like a reduced state.
Yep.
But what was this? What are like surrounding more like prominent theories surrounding what the state of the universe was before the Big Bang happened?
There's There's a book called Battle of the Big Bang that outlines 25 ideas that are all defensible. There's not like one big theory. Yeah, you should get the book. It's a good book.
Which idea do you personally subscribe to?
I don't. I'm agnostic towards it.
Oh, you don't? Oh, okay. Fair enough. Well, thank you, Dr. Blitz. I appreciate the time.
Of course, thanks for being here.
Thank you.
For a second, I thought he was trying to be sneaky and like get me to say something so then he could clip it and say that I'm like a flat earther or something. Also, I'm not sure that he read the paper. One thing that I've noticed is a lot of people have been putting my papers through ChatGPT, which I don't love. But, you know, the more you know. Like, it's not... I get emails that are like ChatGPT generated seemingly rather frequently. Let's bring on Mel. Mel, how's it going? Mel, can you hear me?
Hi.
Mel, what questions you got for me?
I was just wondering, do you have a favorite cork?
I don't know. I don't think I do.
What?
They're all
Really?
annoying.
Oh. Okay. That was it.
Sorry.
That's okay. Thank you.
Of course. Somebody says, why not? So I get emails about like, hey, here's your paper. And then they don't tell me that they put it through ChatGPT, but like, you know, you'll have like somebody who's like, hey, I found this thing I think is a mistake through a paper, which, you know, like it's good to point out mistakes, but they're not always mistakes. Often they are, you know, hidden assumptions that are kind of standard in the literature that ChatGPT doesn't know. And so like, you know, it's just frustrating to get emails from people who don't actually, who don't actually, like the kinds of criticisms that are offered are generally far more technical than the person who's offering them like has the awareness for. So like if like an 18-year-old who's like, you know, I don't know calculus that well, but I think, and then here's like a detailed criticism of like this thing, and it's like, well, it wasn't actually like a valid criticism. There's just some assumptions that are kind of standard that were missed. But like, I don't know, it's that kind of thing. It's kind of annoying. Like I'm fine if somebody actually like has an issue with the paper, that's great. And if they want to ask questions about it, that's great. But like, I don't know. Especially if they're not using like, you know, a good version of ChatGPT or whatever, that, you know, the kind of one that hallucinates and stuff. Anyway, that's a personal opinion. All right, we have another guest from Discord. Let's bring up Nikhil Limgala. Nikhil, how's it going? Nikhil? Nikhil?
Yo.
Howdy.
Can you hear?
You're good. I can hear you just perfectly. Nikhil, how is it going?
It's going, yeah.
Great. What questions you got for me?
Oh yeah. So I'm actually a physics undergrad student.
Mm-hmm.
Went through going into my final year. But
Okay.
I just I took quantum last semester.
Mm-hmm.
And kind of so what really got me into physics like from like early on was this idea like if you can kind of determine everything, right? Everything's deterministic if you knew the conditions and you knew the equations.
Mm-hmm.
So I guess I'm just like conceptually confused about quantum mechanics and this idea that everything's probabilistic. Like I understand all the equations and the math and stuff, but it's kind of like an Einsteinian objection almost. Like
Mm-hmm.
the God doesn't play dice. How do we know that there's no unknown determiners that we just haven't found? How do we know that things are probabilistic? And how can you kind of square that?
Well, all of the evidence that we have says that it is probabilistic. Like it's all consistent with the probabilistic nature of quantum mechanics. Now, what we've ruled out are local hidden variables. These are like effects of, or these are properties of the system that we just don't know how to measure or something like that, that are somehow carried between, say, two space-like separated particles. that carries like the entanglement, or that kind of mimics the entanglement. We know that those have been ruled out. There's a famous experiment or a famous series of experiments conducted in the 70s, 80s, and 90s called Bell type experiments that ruled those out, and the Nobel Prize was awarded in 2022 for this, for these experiments. So that's been ruled out. But there's room for things like called global hidden variables. Global hidden variables could potentially do away with kind of the apparent randomness. But the point is we just don't have any evidence for them existing.
Right. Yeah.
Now, Einstein really wanted there to be local hidden variables, but after he died, we figured out that that's impossible.
Right. I guess like this idea that like something is determined by nothing is kind of, that makes sense. That's kind of throwing me off almost.
You cut out there again. Can you repeat that?
This idea that like that things are truly random, that something like some outcome can be determined by nothing almost, is kind of the conceptual like sticking point for me.
I mean, it just might be how our reality works.
Okay.
I mean, like I understand that it's very intellectually dissatisfying and it feels very wrong, but if that's how our reality is, then it's tough. You know, Neil deGrasse Tyson says, not that I love the man, but he says, like, you know, the universe is under no obligation to make sense to you.
Yeah, that's fair. And then I guess I also wanted to ask you if you had any advice for people trying to get into the field of physics in this climate right now.
Oh, I have none. I don't know what this climate's going to be in 3 years. Like, I mean, not saying that you shouldn't do it. I just don't know what the best advice is. Like, if you had asked me 5 years ago, I would have plenty of good advice because, you know, it was basically the same as what I did. But nowadays, like, you know, I could give you the advice that I would give somebody 5 years ago. I don't know how relevant it'll be, though.
I'll hear that advice real quick if you.
Yeah. So if you're going to university, the first thing that you could do, most important thing if you're going for a degree in physics, is make sure that your math skills are always ahead of your physics skills. Always. And the reason I say that is because that way you are not busy trying to understand the math that happens in a physics class. You're busy trying to understand the physics that happens in a physics class, because there's a lot of math that happens and you don't want to get stuck on the math. It's probably the thing that I saw be the largest stumbling block for my classmates when I was getting my physics degree.
Okay. Yeah. That makes sense.
But who knows with AI, you know, maybe there won't be any physicists in 10 years. So, but there won't be anything in 10 years either. So, all right. Well, Nikhil, I'm going to let you go. But good luck.
Yeah.
Okay?
Thank you for your time. Yeah.
Of course. Take care. Cool. All right, I do have some questions that I missed. It seems when you have debaters on, this is from Dope 23 Island, it seems when you have debaters on, one of the most pervasive issues is that they aren't concerned with whether or not their beliefs are true. Isn't that wildly frustrating? It is wildly frustrating. Also, Allison, 80, welcome to level 1. Thank you for joining, Allison. I do appreciate that. Allison, I wasn't talking about you. I wasn't talking about you with the whole screed on people putting my papers through ChatGPT, although maybe it does refer to you. I think that ChatGPT is going to be fine to understand things like this if you have a paid version. The free version will probably be very confused and will probably tell you lots of wrong things. Has studying physics raised more questions or answers for you? At times it feels like the deeper I go, the less I understand. The universe doesn't owe it to be understandable, of course. Yeah, so I do know more, but I also do have more questions that I wouldn't have even known to ask before. So it's kind of both. I just want to make sure I didn't miss any. Oh, you're talking about the phone call? No, you're fine. Alice, are you Mel? If you're Mel, you're fine. You're good. Can we talk about your collab with Chase? What are you working on? If not, no worries. No, we can't talk about it. I don't even know if I'm going to talk about it after the collaboration is over, because I don't want to, if I talk about it, then, and because his name will be on the paper, I don't want to dox him. I don't know if he's okay with that being publicly known. So, and you know, so it's one of those things where like I would want to protect his identity because he has an online presence. If he's okay with it, I'd be happy to talk about it, but that's, you know, I'm not going to force his public identity to be revealed. But it is, I think it'll be interesting. I'm excited for the work. Oh, wait a minute. So your name is Allison 80. Called me Alice. That was my grandma's middle name. Is your... Yeah, don't worry about it. Nobody's mad at you. Nobody's mad at anybody. Don't worry. Nobody's mad at anybody. All right, so currently there are no questions. You're Allison. Okay, not Alice. Currently there are no questions in the chat boxes, and there's also no guests. Oh, wait, there's a guest. I just turned... I don't know why I couldn't see the guest box. Let's bring up Cherry Bomb Games. I'm sorry. Cherry Bomb, how's it going?
I'm doing well. How about yourself?
I'm doing okay. Cherry Bomb, what questions you got for me? Cherry Bomb? When you're off the app, I can't hear you.
Sorry, usually lets me my screen darken, I guess, in this case. I'm watching your lives for a while now, and like even if I don't quite exactly understand the concept you're talking about, I can usually follow along. The last couple of lives when you've been doing the like logical and philosophy stuff, it felt like my brain was melting.
That's a normal experience, totally normal.
Right, but I'm just like, that seems to be interesting to me, and I'd like to learn more about that. What would you recommend as like a good starting point for that? To start learning about that kind of thing.
Honestly, it's hard to say. Like, you could go look at the Stanford Encyclopedia of Philosophy, which is a really excellent resource. But like, if you're just getting into it, it might be too jargon heavy. So what's definitely worth doing, and this is the only reason why I can do it. Like, I don't read philosophy. It's not like I don't spend my time doing that. But I do have a background in mathematics, and one of the things that you have to learn when you do mathematics is essentially what would be called analytic philosophy. It's like the kinds of argumentation that are formally valid. That's very, very handy for, you know, making sure that your reasoning is precise. And then it's just a matter of learning the jargon, learning the lingo as you go. And I just picked that up kind of by doing it and by listening to it.
Sure. Well, thank you. I appreciate it.
Yeah, I don't know if there's any other advice that I can offer though on that front.
No, that's totally fine.
If you do want good advice though, go talk to Ian. If you know Ian, allegedly Ian on TikTok and all the other places. Allegedly Ian will have probably very, very good advice because Ian got into this kind of as a hobby as well, and also runs a book club and knows a lot more about philosophy than I do, so that might be a good person to talk to as well.
Awesome. Thank you so much. Appreciate the advice, and as always, appreciate you.
Of course. Thanks for being here. Second guess myself too much. Yeah, me too. I get it. We all second guess ourselves. From Ethan, how does a spin 2 massless particle spit out GR in regards to string theory giving it for free? It's... God, I'm going to butcher this, and Chase is probably watching. Chase is the resident string theorist, so... Okay, so... You'll get... okay, so what will happen is that you'll write down the equation of motion for the spin 2 excitation of the string. And the equation of motion is going to be covariant. It has to be, different diffeomorphism invariant, for example. And what you'll find is that it's something like a wave equation, except it's not the only wave equation because it's diffeomorphism invariant. And so it ends up being the linearization of the Ricci-flat condition, if I remember correctly. And I guess you can also add a cosmological constant if you want to. And so that's roughly how you get GR. At least that's how I remember getting GR out when I was taking string theory. But I could be misremembering, and Chase will get mad at me for it. Milk, welcome to level 1. Thank you so much for being a part of the party. Appreciate you. All right, let's bring up Patty K. Patty K, how's it going?
Hey, Dr. Blitz, not too bad. Been watching your streams. Absolutely love the work that you do.
Appreciate that.
Yeah, it got me motivated to also be studying space engineering. And
Ooh,
I
exciting.
have a question about electromagnetism.
Sure, go ahead.
I've been referring to Faraday's law and Ampere's law, and that I know that when light travels, it travels with both magnetic and electrical field based
Yep.
off those two laws because the waves transfer between each other.
Yep.
And in a vacuum of space, they are kind of like seamless with the transitions, which allows light to travel indefinitely.
Yep.
My question is it the waves that are causing the photon to travel, or is it the photon emitting the waves that is causing
The photon
push it aside?
is a wave.
It is. Well,
The
also, would I
the photon is the wave. I mean, it's the smallest chunk of the wave.
Okay, because my professor would tell me that it was more of a packet of energy that could be either a particle or a wave, depending on the selection. Of
Your
the
professor
experiments.
was unfortunately wrong. All quantum objects are waves. They just sometimes behave like particles.
Okay.
So that's why people say like, oh, it's a particle, it's a wave. Like typically when you think of a wave, what we're really thinking of is like a sine wave or like something that is extended spatially. But like you can have waves that are localized, and those are just as wavy as anything else. So they're waves the whole time. And really, when you have like light traveling out in space, photons are not the correct picture to have. You should really be thinking of them as classical electromagnetic waves, because that's what they are.
Okay, that makes sense. So then I should kind of just erase that fact of like, if I'm seeing light travels in space, only think of it as just a wave, whether
Yeah.
it's magnetic and electrical as well.
Yep.
Okay, thank you so much. That actually helps a lot.
Yeah, of course. Thanks for being here. You're a wave, Harry. Yeah, there you go. Is it Malk or Mike? Let's bring up Chesburger. Oh, I'm sorry. I got Zelda will come up next. Chesburger, how's it going?
Yeah, how are you, man?
I'm doing all right. What questions you got for me?
This is gonna sound really stupid, but
There are no stupid
if
questions.
if you go to the end of the universe, theoretically, could you know how there's like a limit to the universe?
Well,
are you like
it's not clear that
stopped?
there is. It's not clear that the
So
universe has
it's-
an edge.
So it's
In fact,
infinite.
it seems likely to me that it doesn't have an edge. Not necessarily. That's also not necessarily the case, right? Okay, so the way to think about this is think about the surface of the Earth, right? Surface of the Earth. It's not infinite. It's very finite. It has a finite surface area, but there's not an edge to the surface of the Earth either, right? So it could be something like
Right.
that,
But if
where it
you're
kind of loops
ins-
back on itself.
If you're inside the Earth, though, eventually you're going to.
I'm not talking about inside, I'm talking about the surface. So we can walk around on the surface. There's no edge to the surface, but it's also not, the surface also isn't infinite. The universe
Is
could
the
be like that.
universe- Is the universe not a container? Like
Sure, I mean, you can think of it that way, but the point is that the surface of the Earth is the container for two-dimensional things that live on the surface of the Earth, right? So
Right.
So the point is that the universe probably doesn't have an edge, but that doesn't mean it's infinite. It could mean that it's finite and it just loops on itself.
And my brain's too small to understand that.
It's a good question. It's not a dumb question.
I feel like it's a little bit dumb, to be fair, because
Nah.
I mean, in space, there's nothing. Well, there's stuff, but when there's nothing, it seems hard to imagine not being able to go out into the nothingness. You know what I mean? Like,
Well, there is
you
no
can't-
nothingness anywhere, as far as we can tell. There's always more stuff.
But you
Regardless
said-
of what direction you go in, it seems like there's always more stuff.
So it could be. Is that obviously they call it observable universe, but there has to be a point where it ends because there's no way.
Why?
Well, I think it's impossible that because we know there's a start to the universe, do we not?
No.
Or a start to creation and stuff. What's the earliest thing we can observe? What's the earliest?
It's called the cosmic microwave background radiation. It's about 13.8 billion years ago.
So if theoretically that was the first thing that we can observe at the moment,
Mm-hmm.
there must be, it couldn't have grown out enough. Maybe we're in the stages of.
So the important thing is that the observable universe is very finite, and we know exactly how big it is. But the observable universe is not the same as the whole universe, right?
Yeah.
Like, the whole universe could be infinite, but the observable universe is finite. The whole universe could be finite, just bigger than the observable universe. And we just don't know, and it's not clear that we will know.
That's actually like kind of depressing to think we won't know the answer to that question.
I agree. I agree. I mean, it's not impossible that we will ever know. We might be able to figure out some other ways to figure out like what kind of structure the universe has, even if we can't go there. But it's a possibility that we will never know.
Wow. Well, thanks for answering my question. That is.
Yeah, of course. Glad I could be of assistance.
Thank you, man. Have a nice day.
Likewise. Take care. From So Awesome, So Amazing, Super Chats get first dibs on Dr. Blitz. That's true. They do. They do absolutely get first dibs. Because I gotta justify it somehow. From Sparrow the Sissy with the question, I have a vague question forming in my head about the strange behaviors of materials at near absolute 0 Kelvin, and how that might complicate the universal heat death. Might still be too broad an idea, though. Well, look, so generally these kinds of near absolute zero phenomena happen for localized systems where you have like solids or liquids. If the universe is going to do a heat death, it almost certainly will not have any solids or liquids left by the time that happens. The universe is all there is, so there ain't nothing to be after an edge. That's also another way of thinking about it. We can distract ourselves from the really big with the really small. True, that's what some physicists do. Is potato mash just Irish guacamole? Yes. Or is guacamole just Central American? Where do what are they called? God, where do avocados grow? It's got to be Central American, right? What's an example from physics of something that doesn't have a cause or known to have a cause? A good example is when a given radioactive nucleus decays. Now we can say that it does decay because of XYZ thing, but really we want to be thinking about an explanation, not a cause, because like when it happens, it's not clear when it's not clear why it happens when it happens. But we can say that it happens because it's unstable. Sorry, kind of new here. Where can I ask questions? Right here in chat. Right here. Let's bring up I Got Zelda. I Got Zelda. Howdy, you're on the show. Gotta unmute yourself though. Oh my god, is Deathless Light in the live chat? Deathless Light is in the TikTok chat? We'll get him up next. I Got Zelda, what you got?
Okay. So the other Ask a Physicist day, I was asked, you were telling me about forces and force carriers and getting into some of the charge stuff.
Yeah.
I completely forgot to say something. So all right. So for the force carriers, as I looked into it, I'm like, okay, that's massless. That's massless. As far as electromagnetic and the strong force, and. Yep. If we find the graviton, I'm assuming it'll be massless.
Probably.
So I'm like, okay, am I onto something there? And that's when I went and said, okay, the W and Z bosons have mass. So I'm like, well, is there anything there? Is it just coincidence, or like why are those?
Well, so
out of
in some sense they are intrinsically massless, but then the Higgs mechanism gives them mass. And the Higgs mechanism gives them mass for the exact same reason why there is a separation between the weak force and the electromagnetic force. Essentially, one way to think about it is that
gives everything mass, though, right? So is it like
no, it doesn't. I mean, it doesn't give photons mass. It doesn't give gluons mass. Probably doesn't give neutrinos mass.
I'm sorry, everything that has mass.
Right.
The Higgs.
But the point is the Higgs mechanism was originally conceived to explain the mass of the W and Z bosons specifically.
Okay.
So the idea is basically the Higgs boson, when it's in its unstable configuration, doesn't give anything mass. But at some point in the very early universe, it descends down, it stabilizes, it kind of drops down into a valley where it's stable rather than being unstable at the top of a hill. And in doing so, it gets something called a vacuum expectation value, which means something like there is a certain amount, or there is a even when there's nothing going on with the Higgs field, it still has a value. It's not just sitting at zero.
Yeah.
And
Not that I
so-
understand it, but I've heard that before.
But the point is that once it's down here in this valley, it can oscillate in two different ways. It can either oscillate kind of in the direction that makes the valley kind of like go up and down, or it can kind of oscillate in a flat direction around. And the flat direction gets eaten by the W and Z bosons. And by eating that, and this is like a technical term, by the way, by having that mode get eaten, they accumulate mass.
Okay.
Basically, they get an extra degree of freedom, and the only way that a massless thing can have an extra degree of freedom is if it suddenly has mass, because only massive things have 3 degrees of freedom.
Before that, they're massless, and then when they do the eating, it gets.
Yep.
Okay.
Then the point is that so there were 4 bosons as part of the electroweak gauge theory. There was B+, B-, B0, and there's another. Do they use C maybe?
I don't. You're beyond what I know now.
But the point is that some combination of those were the ones that ate the massless mode from, it's called the Goldstone mode, that ate the massless mode and got mass, and then there was one left over just by counting, because there's only 3 that could get the mode. The one left over is the one that became the photon, because it was the only one that remained massless. And the way to see why this is intuitive is because the
this
W.
All part of
oh, go ahead.
The symmetry breaking.
It's
like
exactly
when
that.
It's originally separated or whatever. Okay.
Yep.
I didn't mean to interrupt. I just wanted to make sure I'm right track.
So the interesting thing about this is that if you look at the Z boson, except the fact that it has mass, it's almost identical to the photon in every way. It basically does the same thing that a photon does. It's just heavy, and it interacts with a different kind of charge. But otherwise, like all of the mechanics is basically the same. So you can see how they might be related. The W and Z bosons are a little bit different because there's some extra charge, but the Z boson is very closely related to the photon, and they are cousins. It's just one's kind of put on a few pounds.
Okay. I'm pretty sure you told me this last time. Catch it. At that time, I was just still confused why there was 2 weak force, whatever.
Mm-hmm.
So I assume one is for the radioactive decay, and then what's the other one? They're
not really for anything. They're just 2 different kinds of charges. But the point is that so
are
because,
they the same? They're the same except for the charges? Or they have different properties?
They have different properties because they interact with different charges. They kind of split along the 2 different charges that they can interact with. So the W boson interacts with weak isospin, and the Z boson interacts with weak hypercharge. And so the W one, because it interacts with weak isospin and it has electric charge, it can't do like the kind of forcing that you expect. Like it can't push on things without changing them, because to absorb a W boson or to emit a W boson in order to conserve electric charge, because the W boson is electrically charged, it would have to change the charge of the thing that it's interacting with. So that's how you get kind of decay, because you get transmutation of particles.
This charge you're talking about is a weak force charge and not a...
No, I'm actually talking about electrical charge here. The reason, it's also because of the weak force charge, but even just the electromagnetic charge, because it has electromagnetic charge, it can't just push off a particle. If it's going to be absorbed or be emitted, in order to conserve electromagnetic charge, it would have to change the particle that it's being absorbed from or being emitted by. Okay. Right? Like think of like a neutron emitting a W minus boson. Well, where did that negative charge come from?
Unless it's losing something.
Right. So it has to get so when it does that, it can become a proton, which has positive charge, so that the net charge is still the same.
Is that the decay? That's exactly
that's the idea.
What.
Yep.
Yeah. So now that leads into. Or do you still have more to say? Or?
No. You're good.
Okay. That led me into. I don't know what the word would be. Just not inherently, but just thinking of radioactive decay. You're thinking you're losing something. So I'm thinking I'm always going down in the periodic table, and I find out no, you can decay into a higher element.
Yep.
And I found out that's basically what it told me is if it has more protons, a proton will decay. If it has more neutrons, a neutron will decay, and that decides it.
That's usually so in a nucleus.
And I know it can kick 2 protons. I know there's more than just that, but
so in a nucleus, there are configurations that are more and less stable. So generally speaking, when there's not so many protons, because protons are electrically charged, so they want to separate from each other. So when
stability, are we talking isotopes, or are we talking?
Yes, we're talking isotopes.
Different stability. Okay.
Yeah, isotopes. So when you don't have too many protons, atoms tend to want to have roughly the same number of protons as neutrons because of basically complex quantum mechanics. If they're balanced, then it costs lower energy than if they're imbalanced, which is why like the light elements tend to have the same number of neutrons as protons. As you get higher in proton count, these nuclei, they want to have more neutrons than protons because the protons basically act as glue for the protons, because the protons want to repel each other. And so it's just the case that for any given element, there's basically a most stable isotope, which,
so the neutrons are just putting a little space between the protons, and that's what makes it
It's not quite
stable?
that simple, unfortunately.
Okay.
It's that protons are attracted to neutrons, neutrons are attracted to neutrons, and protons are attracted to protons a little bit if they're close enough. And so just by having more neutrons, you kind of give a little bit more stability because there's more attraction to go around everywhere. But the point is that if you have an isotope that's away from kind of that magic, it's not magic, from kind of that maximal stability condition, then it will have a tendency to decay to whatever's more stable. Which can be either increasing the number of protons if there's too many neutrons, or increasing the number of neutrons if there's too many protons.
Yeah. Okay. Keep going. I have another thing about this stuff. If I got notes this time, so.
All right, it's got to be quick though, because I do have a bunch of guests that want to come on and ask questions.
Okay. Okay. Yeah, I only jumped in before because I can only see Discord. I was like, "There's no guests, so I'll jump in."
Yeah. No, I get that.
All right, so let me see. Was it you? I watched too much stuff. I'm pretty sure it might have been you that said gluons are energy and not particles.
No, I would never say that. It wasn't me.
Okay. I might have misunderstood something too. So they are particles.
Well, they're waves that sometimes behave like particles, but they're definitely not energy because nothing's energy.
But not energy. Okay. That solves. I don't even have to go any further. Then that's great.
Okay.
Because the next question, if it's energy, what does this mean?
Sure. Makes sense.
Okay, okay. One last one. So the charges in, like inherently I would think most of us can understand electromagnetic charge because we know magnets and stuff like that.
Perhaps.
Yeah. More so than other charges, let me put it that way.
Sure.
That leads me into the color charges. Is there a differentiation there, or is
Not
it
really.
like it's propulsion and
a green
attraction
color charge
and...
attracts an anti-green color charge? That's still true.
Okay.
But also red attracts green and blue.
I'll have to read the rules, but if it still attracts, if I can still think of it that way, then
it is a little bit more complicated, but yeah, that'll be good enough.
I assume. One day we'll see. Maybe next year I'll ask you. Okay,
Sounds
great.
good.
I appreciate it. One thing non-scientific. At the end of the last stream, you said I was a chill guy, which did more for me than all the science stuff because I've been a little agitated lately. So like you saying that literally just reminded me like you are a chill guy. Just calm down sometimes. So
yeah, just calm down.
Probably more
Zelda, you're a chill guy.
And the science stuff. So appreciate you always, man.
All right,
take it
care.
easy.
All right, we have some super chats to read, some questions to read, and then we'll bring up our next guest, Deathless Light. From Literally Lou with the $5 Australian, as always, appreciate you. Well, I appreciate you too, Lou. And from One More Skateboarder with the $5, 3 polarized lenses in a line. The middle one can adjust the dark to light. Is this a quantum particle party trick? Bell's theory, right? It's not really. It's not like you don't have to think of it quantum mechanically. It is sufficient just to think of it classically. Like, just think of how much light is actually passed through as a result of each subsequent polarizer. And note that the polarizer isn't passive. It's not just a filter. It actually changes the electromagnetic wave. That's the important point, right? And then you don't need any quantum mechanics to explain this at all. I mean, fundamentally you do, but like to understand it, you don't. And then we have some questions I think that I should also answer before I get to Deathless, but I promise we will get to him. I often see in physics circles people talk as though Hawking radiation is a fact, even though we have never observed, and a lot of research has actually gone into explaining how info is encoded into it. How sure are we that Hawking radiation exists? We're pretty damn sure, because Hawking radiation doesn't require anything fancy. It just requires curved spacetime and quantum field theory. That's it. And we know that both of those are like really good models of the way the world works. And so if you put those two things together, Hawking radiation just happens automatically. Just want to make sure that I don't miss any. Does that say there are different kinds of light? Yeah, there are different kinds of light. Some are, some is high frequency, some is low frequency. Can a wormhole open in a black hole? Probably not. They'd be very, very unstable if they could. Okay, I think that's everything. We all understand EM charges. Sounds like someone who hasn't had to deal with Jackson's textbook. That's so true. That's so true. Is Dale calling to ask a question or debate, or to perform or crash out? All right, who knows? Let's ask him. Deathless, how's it going?
What's going on, guy? So I want to
What you got
invite you to
for me?
participate. I want to invite you to participate in a project with me.
What kind of
I'm
project?
dead serious.
What kind of project?
So I have a scientific model of God that I think is empirically testable.
Well, that'd be crazy.
And well, so here's my concept, and it's gonna piss off absolutely everybody, because it pretty much obliterates everybody's religion and their philosophical concepts if it turns out to be true. But I think I know what God is from an empirical level, at a level that we could test, and it's a no-nonsense idea that's based off of relativity theory, some elements of quantum mechanics, and the block universe. And I'll explain. So, presuming that technology advances every 18 to 24 months, and according to Moore's law, with an exponentiating rate which is approaching an ultimate limit, c, which is the fastest to which anything could actually progress in the universe in terms of any acceleration whatsoever or movement, then what we're actually instantiating is that technology, as it advances in terms of its information processing capacity, it's approaching the speed of light. Any sufficiently integrated quantum system of intelligent observers, which are coordinated into singlet states, such that they could be treated as a total system, should they ever actually reach C with respect to the rate of their technological evolution, 100% of their inertia will be subtracted out of space, put into time. They'll go non-local as observers. And
So,
because they go non-local...
technological...
I'm almost done.
Yeah, sure. Okay, go ahead.
I'm almost done. Because they're going to go non-local as observers, the wave function of their consciousness will go non-local as well. They will experience all places and all times simultaneously from the point of view of light, which is what light is and what light perceives. It will do a simultaneous observation of all information in the wave function everywhere, all at once. All information everywhere in the wave function will instantaneously collapse, actualizing all logically possible universes across all multiversal possibilities and potentialities. In consciousness itself, of the observer that's intrinsic to the wave function, instantiating the actual the consciousness of the civilization itself to be that which was the mind of God that bootstrapped the universe from the beginning, from the moment of the first primal point of the atom to the point of the actual heat death of the universe, or prior that, or post that, so that we could actually have a retrocausal tachyonic theory of ontogenesis. So in a nutshell, how I would probably try to explain it is simply this. Let me make it super simple. If a species of intelligent life ever began to process information at the speed of light, the first person subjectivity of that species with respect to its information processing would be at light speed, and that would be non-locally distributed. All possibilities in observation would be actualized simultaneously by a universal observation, collapsing all possibilities into experience actualized everywhere. That would instantiate a block universe direct in perception, and that block universe direct in perception would satisfy all symmetry conjugations between the actus purus of Thomas Aquinas's theory of God as pure act with fully exhausted potential, while at the same time being completely symmetrical with Einstein's theory of the block universe. And I think we have a theory of God that could be tested.
So the speed of technological advancement is not a speed in meters per second.
That's just not true. It's just not true.
Sure it is.
It's here's the thing.
Moore's law
Absolutely.
doesn't tell us anything about it, like a distance divided by time. It's not a speed in meters per second.
So all we would have to do,
also, Moore's law has already failed. Like it's not true anymore.
Great. All we would have to do, yeah, it's actually advancing faster. We know that. So all we would have to do, listen, all we would have to do is just devise a mathematical metric by which to demonstrate that technology evolves at a speed which is in relation with a vector in time toward a limit.
A speed is like a distance over time, though, right?
And
so like it's not really like I don't quite know how you would compare that to technological advancement.
I think we could probably do that. I think that if you and I sat down and we put our fucking heads together and we came up with something creative, look, I'm not fucking with you. I normally don't like you, but I figured like this would be a cool idea. And I thought I sought you out because you're the fucking easiest physicist to reach. And I personally think that if we did this, and if it turned out to fucking be legitimate and it was real, it would have civilizational changing implications.
I think that you have to find another physicist, because I think it'd be a waste of time, to be honest. Like it seems confused. And I don't mean like for what it's worth. I don't mean that to like just be rude. Like I say this to a lot of people who bring up their ideas to me.
I understand that, but there's missing pieces. Hold on, there's missing pieces of information, and I've been able to achieve pretty astounding things in the field of philosophy from missing pieces of information. Look, let me explain something.
There just seemed like there was a lot of physics that was going misunderstood there. That's all.
I don't think I'm misunderstanding the physics. I think you're misunderstanding my language. So here, look. Speed is a rate.
Speed is a distance over time. It's not just any rate of change.
Of course. It's a distance over a rate between what? But distance itself, when we're saying that it's distance only with respect to an Einsteinian or Euclidean metric, that's an arbitrary determinant. All you have to do is just change the paradigm, and then you could graduate to a different system.
But the point is the speed of light is only concerned with distances in a space-time.
If we could conserve the actual mathematical operations into a different paradigm, that becomes a moot point.
But then we don't have any reason to think that the speed of light is a limit.
If
we're not talking about actual distances, there's no reason to think that the speed of light would be a limit at all.
Only according to the paradigm that we left behind. What I'm suggesting is a new paradigm of things. So what I'm suggesting is that
what would the speed of light be with if you're not talking about distance?
So in this particular instance, the speed of light would be metered against probably the rate of change in Hilbert space.
Hilbert spaces don't have distance metrics. I guess they actually do. Well, they're metric spaces. They don't have distances though. Distance is not in the spatial sense.
Not in a physical concrete sense, and absolutely not.
Right, but that's what the speed of light is about. The speed of light is about concrete distance covered in a concrete amount of time. So like there's just no reason to think that.
I agree with you. I agree with you on that. But to have the concretes, you have to have the abstracts first that work in principle. And that requires that speed actually have some sort of platonic structure.
But like what I'm getting at is that the reason why there's a speed of light limit is because like when we're talking about relativity is because we're talking about an actual speed through actual space through actual time. There's no reason to think that if you're talking about some more abstract space like a Hilbert space or something like this, that there would be a limit like that.
Here's one of the difficulties that you're running into, and I think this is where my expertise could probably help you out. Space and time are just intuitions of the psyche. Here's how and why. These are a priori categories of how that are preloaded as kind of a software that enable us to make empirical measurements. Space and time have no existence independent of the intuitions of the observer, and they can't. Here's how and why.
I mean, that's debatable. Like the discovery of gravitational, it really is. The discovery of gravitational waves is pretty. It's a pretty solid nail in the coffin of space-time relativism or space-time conceptualism.
That's completely irrelevant. Here's why.
Not really, but go ahead.
First we got to go back 200 years to Immanuel Kant and Critique of Pure Reason. Now, what Immanuel Kant discovered is that you can't even have the concept of 2 being greater than the number 1 without space-time. So he said, because you cannot have the actual concept of 2 being magnitudinally greater than 1 without presuming space-time, space and time are a priori the concept of the number line, which means that you have to assume space-time even to take measurements of the empirical experience, which means space-times are fundamental assumptions of categorical structures a priori to the intuition of the logical observer. Now, because you cannot actually have you cannot have space-time mind-independent, because space-time mind-independent still presumes a mind-dependent structure of intuition by which to actually hold the symmetry. It means that space-time is only an instinct of how human beings sort perception, and that's all that it is.
That's a really big claim.
it turns out to be true for 250 years.
I don't think
Now,
that's true.
Well, let me ask you something. Does space-time have geometry?
Yeah.
That means you're actually using an a priori concept of space-time to standardize a different concrete form of space-time that has shape already. So what is the actual shape of space-time if shapes exist in space-time? That's the whole point he was saying. You can't have a triangle that exists
Kant definitely
in space
wasn't talking about
if
this,
space
by the way.
itself is a triangle. Excuse me?
Well, yes, you could. You could just have a smaller triangle inside the bigger triangle, for example. Kant wasn't talking about space-time either.
No, that's just a self-recursion.
No, I mean, like, you can have circles inside of circles. There's no issue with there.
If
Like,
you're looking, excuse me, if you're looking
there's
at
no issue there, right?
If you're looking at conformal geometry, to which the ratios of the circles are the same, and a parachoretic distribution of the holographic principle, then at some point, if the actual ratios are 100% transferable across a limit, so that it could be converted without information loss to the same circle, just appearing in two places at the same time.
That's assuming that we live in a conformal structure, not a Riemannian or Lorentzian one. Like,
Riemannian and Lorentzian ones are still conformal to their own interior mathematics. We both know that.
That sentence is not like sensible. No, it doesn't mean anything to say it's conformal to its own interior mathematics.
Yes, it does. I'll tell you why.
Okay, what does it mean for something to be conformal to interior mathematics? What does that mean?
Sure, I'll explain. The number 2 is a recursion of the number 1 twice, which means it conforms with itself across an iteration of a factor of 2.
Conformal doesn't mean conforms to. It's not what conformal means.
No, conformal means it recurses the pattern. It's self-recursive.
No, it doesn't. No, that's not what conformal means. At least not in the context of conformal geometry, it doesn't.
Read Roger Penrose's Cyclic Conformal Cosmology. It's a good
I'm familiar with Roger Penrose's Cyclic Conformal Cosmology.
But have you read his treatise? Because that's how he uses it.
Have you read? You know his treatise is like 1,200 pages long, right?
I've read it.
What's the name of the book called?
Cyclic Conformal Cosmology.
No, it's called The Road to Reality.
No, I've read Cyclical Conformal Cosmology. I downloaded it back in like 2017. It took me fucking forever. I didn't understand half the math, but I understood the concept.
I mean, the treatise, maybe you're referring to a specific paper. The treatise is called The Road to Reality, which was published, I don't know, 10 years ago, 20 years ago, something like this.
Here's what he said.
But anyway,
he says, hold on, excuse me.
If Penrose says that conformal geometry is just self-recursively, my point is I haven't read The Road to Reality. I haven't read it because it's so goddamn long. I've just read papers about it, so I know what the idea is.
It's enormously abstruse.
But my point is that if Penrose says that conformal geometry is cyclically recursive, then he's just wrong about that.
Here's what he says. He says that the actual he says the late stage conditions of a universe in which everything disappears into black holes eventually achieve that through Hawking radiation, all the black holes eventually evaporate. When all their interior elements are actually evaporated across the universe, and there are no observers by which to actualize any sort of topology, so that everything is distributed across a perfectly homogeneous. You could say a perfectly homogeneous plane. It's not a plane he uses. He says the indistinguishability between any 2 points A and B is identical such that any 2 points A and B become identical to the same point A and B, so that the actual cyclic conformal structure of it is identical to a mathematical point that just detonates out from its own initial conditions from the very beginning. It's a brilliant idea.
It's a little mistaken. I mean, like the way that you described it is a little mistaken, but it's roughly it. But the point is that conformal cyclic cosmology is not all conformal geometry. Conformal geometry is not just that something is, recursive. It's not what conformal geometry is.
How he describes it. So as a systems theorist, I'm probably using a more technically accurate definition of recursive than you probably understand. So recursive is just basically the capacity of a system to return to its starting point.
Yeah, that's not what conformal geometry is about.
If you're now conformal means the capacity to return to a starting point between initial conditions.
That's not what it means in the context of conformal geometry. It's just not.
So then we're using two different sets of jargon. We're talking past each other. This is what it means in
but the conformal geometry that Penrose was using is the kind that I'm referring to.
Okay, so because I'm using a systems definition, how is that defined in your discipline?
So conformal geometry is just the geometry of spaces without distances and rather angles only.
Okay, so if there are spaces without distances rather than angles only.
No, so like a normal Euclidean space or like a normal Riemannian space, this is a space that has both distances and angles, right? So you can measure the angles between things, but you can also measure the lengths of things. Conformal geometry just forgets about distances.
Great. Okay. Fantastic. So let's bracket this in our phenomenology, and let's triangulate what you basically stated, so we could terminate by putting our analysandum on the analysands of our observation, and let's just see what we could do about making a concise infinitesimal with respect to a definition. Okay? Now, in this particular instance, you said that conformal means the measurement of change without respect to distances. Did I get that correct?
It's not the measurement of change. It's just the geometry of angles alone, rather than angles and distances.
So it's the geometry of the angles alone, without reference to physical change, correct?
No, without reference to distance.
Without reference to distance. Thank you. So it's the geometry of angles alone without reference to distance.
Yeah.
So if you could have angles without reference to distance, where do those angles exist?
In the conformal manifold. Between points in the conformal manifold.
Thank you. And the conformal manifold is effectively a mathematical phase space, correct?
It's not a phase space, but you could call it a configuration space if you wanted to.
Well, a phase space and configurations are synonyms. They mean the same thing. So
No,
you have
they're not.
configurations. Yes, they are.
No, they're not.
Yes, they are.
At least not mathematical physics, they're not.
Excuse me. A configuration space is just a space which indexes an ordinality. A phase space is which indexes an ordinality as it expresses itself through time. Let's just not pretend like we both don't know what we're talking about.
Well, I'm not the one pretending that we both don't know what we're talking about.
Look, here's the thing. We both know that I'm right about what I just said. We both know that.
Sure. Let's go with that.
Yeah, look, here's the thing. See, I'm taking you seriously, and I'm trying to do my best to talk to you. And I know that you're getting embarrassed because you know that I'm able to clip you on this. And you know
that's what's going to happen. You're definitely going to clip me.
Excuse me. So let's get back to this. If you're dealing with a mathematical abstract space, all right, a phase space is the degree to which the mathematical space is extended across cross sections to a limit. That's what that's for. And you can posit a vector. That identity
a phase space is a space of positions and momentums for a system.
I just said that.
You didn't say either of those words.
So excuse me. Watch this. So if you have a cross temporal map of an ordinality of a geometric architecture within any cross section of a phase space, or any cross section of a space, like a Hilbert space, but then you extend to a second state in T2 so that there's an identity bridge which posits a cross-temporal mapping between phase relational configurations of any two states A and B. All you're basically doing and objecting is to the fact that I'm using the same exact model that you're using iteratively.
I'm not even objecting. I was just correcting your language so that it's technically accurate.
No, here's the thing. I'm speaking in systems theory jargon. You're speaking in physics jargon. If you don't know how this works, physics jargon answers to systems theoretic jargon. It's not the other way around.
Literally,
you have
I've never spoken with a physicist who has ever mentioned a systems theorist ever. I think that you have a little bit of like an ego issue here, that you're like
allow me to explain.
Systems theory is on top of physics here.
Excuse me. Here's what general systems theory is. General systems theory is the semantically irreducible, non-negotiable meanings of interdisciplinary terms to which any specialized set of jargon has to be consistent with, in order for that specialized set of jargon to actually be communicable with other disciplines. If your unique set of language terms doesn't match to this language model, your language is wrong. It's not mine.
I guess, Deathless, I guess you're right. I guess I'm too dumb. I don't understand systems theory, so I can't help you with your theory.
That's not what's being said.
Sorry, Deathless, I wish I could help you. By the way, I genuinely wish I could help him. Yeah, I've never clipped a Ask a Physicist conversation before. This will be a first. I wasn't trying to debate with him. I was just trying to correct his language. It's not a debate day. From Grimmy with the $5. Until God grants Blitz the ability to blot out the sun, or at least make it less intense, God shall be rejected. True. That's true. We do have some guests. So we'll bring up some more. From Garain with the $5. Moore's law hasn't held for over a decade now. Also, it's specifically about transistor density, not all technology generally. Yeah. There was so much wrong in just like the first 30 seconds, and then he just started spouting jargon, nonsense jargon words about quantum mechanics, and it didn't make any sense. From DeForce with the $5 Australian, I think DL just discovered what happened to the Dwemer. Any Elder Scrolls enjoyers? Oh, I don't know what that is. From Garain with the $2, never mind, he's just spewing word salad, always. From Zach with the $5, is this the scientific revolution Thomas Kuhn spoke of? We must abandon our old paradigms. True, we did have to abandon our old paradigms. And from Garain with the $2, you have the wrong kind of doctor to help that guy. Yeah, fair. All right, I have some regular messages to read. Those are supposed to be guaranteed, so I'm going to read those, and then I will bring up another guest to talk to. So let's do that really quick. Just want to make sure that I'm I just want to make sure I find like actual questions. Yeah, so everybody was mentioning about how rate of change is not the same thing as a speed, which is totally reasonable and totally true. Yeah, I'm not doing anything with someone who's as big of a narcissist as Deathless Light. That's true too. And also, he just came up and he said that he didn't like me. I was crazy. Didn't appreciate it. The distance is the size of the technology that comes out of the factory. True. The bigger the distance, eventually we will reach the speed of light, where the size of the technology grows by at the speed of light. I don't actually know if there are any actual questions here. If you have an actual question that went unanswered, just ask it again, because there's so much commentary, which is totally fine, and I appreciate the commentary, but there aren't actually questions. All right, we do have Depressed Clown, who's been waiting for a while. Depressed Clown, how's it going?
Good. How are you going, Blitz?
I'm doing all right. Sorry for not bringing you up in front of Deathless Light, but Deathless Light is a character, and I had to bring him up first.
No, that's quite all right. That man is at the top of my nightmare blunt rotation list.
Right? So, all right. So, what questions you got for me?
Okay. So I'm a mature age student, and I've just I'm starting engineering, and math has been a bit of a slap in the mouth. Are there any resources that you would suggest for a student?
Well, okay. There are a lot of resources online that you can find, like MIT OpenCourseWare. You can find Khan Academy. These are kind of like the obvious ones that people mention all the time. There's also various YouTube channels that do a lot of like, I don't know if remedial is the right word, but like kind of catch-up math that might be helpful. It really depends on where you are, which math is the part that you're struggling with, to figure out what you should do next. How's your algebra?
Algebra's fine. It's just calculus that I'm struggling with.
Okay, so often what happens, and I'm not saying this is for you, this is why I brought this up earlier. Often what happens is that somebody struggles in one math topic because their foundations aren't particularly good in the stuff that they need in order to do that math topic. But it doesn't sound like that's the case, because generally you just need strong algebra skills in order to do all right in calculus. So in your case, it very well could just be the case that you need to see these subjects or these topics taught in a different way. And so this is exactly what MIT OpenCourseWare is good for, what Khan Academy is good for, what YouTubers are good for. You can go look up other lectures, you can go look up other textbooks. Generally, if something doesn't click the first time around, because for whatever reason, it's just because the medium didn't align with the way that was most effective for you. So what I would suggest is, for whatever topic you're working on in your calculus class, and there's probably going to be some catch up that you have to do, go cover those again. Look for resources, on YouTube, Khan Academy, MIT OpenCourseWare, again, that will cover those topics in a different way. And that will at least hopefully shore up the ideas so that it kind of clicks in your head.
I really appreciate it. And you said MIT OpenCourseWare?
Yeah.
Okay, brilliant. I have more of a science question, and it might be a silly one.
There are silly questions, just no stupid ones. Go ahead.
Is there a fundamental distance in physics?
In some sense, there's a fundamental distance it's fundamental in the sense that it's like, determined by the laws of physics itself. It's not something we impose on it, but it's not necessarily like the smallest distance or the largest distance. So it's the Planck distance, the Planck length. It's about 10 to the minus 35 meters, or is it centimeters? It doesn't matter. It's very, very tiny. And basically it is, we get to that number basically by just considering various constants of nature. So things like the speed of light, the gravitational strength. I guess the gravitational strength's not involved. The speed of light, Planck's constant, and so on. And if you combine them in just the right way, you get a distance out. And so that's all that's happening here. Now, what that distance represents, it probably represents, yeah, Chase is saying that's where the strings are. It probably represents where gravity starts to play a role at the quantum scale. But it's not necessarily like a minimum size.
So why is it that like gravity, like at those small scales, starts to break down, or not break down, but not work as intended?
So the intuition is just that in order to get to those distance scales are determined by the strength of gravity. If gravity was much stronger, then those distance scales would be much larger. Because one could, for example, one could figure out sort of a similar thing for like the length scale associated with like the energy of an electron or the energy of a proton or something like this, and this would tell you on roughly what scale. Because you include h bar. If h bar is included, this is Planck's constant. It means that there's some quantum behavior. This would tell you on roughly what scale electrons start behaving. They can't really be described classically. Like if you get too close to an electron, it stops behaving like a classical point charge and it starts behaving like a quantum object. And so the idea is that because you're combining the constants from these different subject matters, it implies something about the way that those kind of subject matters behave at that scale. Because if the gravitational constant was bigger, we would expect gravitational effects to be more significant on a larger scale, and vice versa. If gravity didn't exist, we would expect there to be no quantum gravitational effects. So it's just an intuition thing, and there are probably ways to formalize it, but that's the way that I come to that conclusion.
And like, how long ago did they like come to this understanding? Like,
I don't actually know the history there. I don't know the history of these natural units. It's not that new, no. So Planck units, I guess they were actually first proposed in 1899.
1899?
Mm-hmm.
That's insane.
Yeah. So take it.
There are
but
some
they didn't know about quantum.
Insanely smart people out there.
So they didn't know that this is. They didn't have the idea of connecting this to quantum gravity. They didn't even know what quantum mechanics was at the time. But this is Max Planck, who they're named after, saying, yeah, if we add this one additional unit, he called it a constant. We now call it Planck's constant. Well, then we can combine that with the speed of light and the gravitational constant, and we can figure out a whole bunch of kind of natural units. Now, the understanding that those natural units are in some sense related to like quantum gravity or whatever, that's a different story. I don't know when that came about. Let's see. Maybe the Wikipedia article says something about it.
What made him think like that? Like, what made him think of that exactly?
Well, he came up with this constant, or he kind of theorized this constant, because he was trying to explain why. Okay, so when you heat something up and it glows. Like the hotter it gets, the more it glows, and the brighter it glows, and the color changes. He was trying to explain basically that phenomenon, and up until Max Planck comes around, there wasn't really a good explanation as to why the kind of relationship between the color and the intensity and the temperature, why that relationship was the relationship. And so this was the problem he was trying to solve. And in doing so, he introduced this new constant. This is how he ended up solving the problem. He introduced this new constant that we now call Planck's constant. And once you do that, and there's some other stuff that goes on, then everything kind of falls into place. And he's like, well, I have this constant. I guess if you combine this constant with these other things, with the speed of light, the gravitational constant, you can just get distances out, or masses out, or times out, or all these other, like, you can come up with something called natural units, which are units that are determined solely by the constants of nature, not determined by some arbitrary thing that we impose on nature. Like a meter is just a thing that's like
that big,
it's not like some fundamental thing about nature, right?
Yeah.
But the constants are. And so the idea is that if you can combine the constants in a way to produce something that has, units of length, for example, well, then that's a fundamental length. Like, for example, imagine that there was so it's really hard to actually come up with, like, the simplest example requires knowing what these things are. But for example, if you take Planck's constant, which has units of energy times seconds, so it's joule seconds is what the units for Planck's constant are. If you multiply that by the speed of light, you will get energy times meters, and if you divide that by Newton's constant, you will get kilograms squared, because Newton's constant has the right units, so that it has units of meters squared per kilogram squared. Meter squared per kilogram squared per Newton. So, but the point is if you take the Planck's constant times the speed of light divided by the gravitational constant, just by the way the units work out, you have something that has units of kilograms squared, and so you take the square root of that, you get something that has units of kilograms, and those are all numbers that are just determined by nature, right? There's nothing that we've imposed on anything. That's just the unique way that you can combine those numbers to get a kilogram, and to get units of mass. And what you find is when you combine those numbers, you get something like 21 nanograms or so, and that just is the fundamental mass of, fundamental mass scale of the universe. It's 21 nanograms, which is 21 micrograms, which is kind of weird, but it is.
So 21 micrograms. What is that the fundamental weight of? Just
so one way that you could think of it is that's the mass of a black hole that has a Schwarzschild radius that is 1 Planck length across.
Okay. I 100% believe you. It's
I know
over
it was
my
a
head.
lot. I know, that's fair.
One final question.
Yeah, sure.
Someone mentioned a video game before. You said you didn't know what the Dwemer were. Basically, dwarves, but like elves. Anyway, it's weird. In Skyrim.
Sure.
But what video games do you play, if you play video games?
Lately I've been playing a lot of Pal World with my wife, which is a great game. I mean, it's definitely a ripoff of Pokemon, but it's super good.
Is that Pokemon but with guns?
Sort of. It's so those survival games. Did you ever play Ark Evolved or
Yeah.
Yeah, it's like Ark Evolved, except replace the dinosaurs with Pokemon. It's basically that.
Okay, that's pretty sick.
Yeah, it's pretty great.
Okay, I'll have to have a look at that.
Yeah.
And I said one final question, and
That's fine.
it's
Go
just
ahead.
it's led to another one. Is there a sort of a classic game that you always your comfort game?
Yeah. Okay. So it used to be. So I played RuneScapes from 2002 till 2022, maybe 2023.
Wow.
So I had an active subscription from 2006 onwards.
Crazy.
I still have the account. I just haven't played it in 5 years because I kind of got bored of it and the microtransactions are terrible.
After that many years, it's fair.
Overwatch kind of fills that role for me now. So if I ever want to if I ever want to just
really?
yeah, I started playing Overwatch in 2016 when it came out, or shortly after it came out, and it's just always been a good game. So
yeah, I guess I thought a more cerebral game would have been, but I guess that's your job. So when you want to relax,
there is something to be said. So there was a summer, it was summer of 2021 or something like this, where I got into Factorio.
Oh hell yeah!
And I spent so much that game's crack to me, and so I had to cut myself off. I can't play it anymore. Because it turns out I do love trains. And so, here's me just spending losing entire days just optimizing train routing or so I can't do that anymore.
That's so funny. I guess you would be the same with something like Dwarf Fortress.
Yep. I've avoided that one for the same reason.
Thank you so much for answering my questions, Dr. Blitz. I really appreciate it.
Have a good one.
And you have a lovely...
I cut him off too early. I thought that was the end, but he was still going to ask him questions. Anyway, so it is... I know that there are a lot of you guys in the guest box who have been waiting to come on. We will be live again tomorrow for more Ask a Physicist, and there will be an hour and a half of Q&A that you guys can pop in to ask questions for. But I do have to end the live now because I have to eat some lunch and I have some work to do. But before I go, make sure if you want to ask your questions and get your questions definitely answered during the second hour and a half of the Q&A, make sure to become a member on, whether it's on TikTok where you can become a super fan, on YouTube where you can become a member, Twitch where you can become a subscriber. It's $5 a month and it helps me out a lot. Now I do have two more super chats to read and then we'll call it. From Pensive with the $20, more lava lamp donations. Crap hands. Thank you so much, Pensive. And from Kelly Scher with the $10 for kitty food. Indeed, I will need the kitty food funds. Thank you guys so much, and I will see you guys tomorrow.